Good morning, everybody. We'll be starting in just a moment.
Okay, all right.
Okay, morning, everybody. Welcome back to SCaLE 22. You're at the Postgres at SCaLE room. This morning, we're very happy to welcome Dr. Henrietta Dombrovskaya. She goes by Hetty. She's going to talk about pgBadger and PostgreSQL. Dr.
Great. Right. Thank you for the introduction. And yes, today we will be talking about pgBadger. And most of you probably use pgBadger, but we will be talking about it in a new way. All right? So let's start. Okay. Does it? Okay. Okay. Oh, sorry. Okay, here. So who am I? So I'm Hetty Dombrovska. I live and work in Chicago. I'm database architect for DRW Holdings, which is an international trading company. We have offices all over the world, but the headquarters in Chicago, and that's where I live and work. Also, I'm a local organizer of the Chicago PostgreSQL user group, which is one of the largest Postgres user groups in the Western Hemisphere, and one of the oldest, I think, continuously operating. So the group started in 2011, and I lead this group since the end of 2016. Also, I am an organizer of PG Day Chicago, and this event is coming on April 25th. I will give more advertising about PG Day Chicago at the end of my talk. Also, I founded Prairie Postgres non-for-profit. That's non-for-profit which covers Midwest states, and with the goal of supporting education in Postgres. So again, I will put more advertising at the very end. And also, I'm the communication chair of the ACM Chicago. So yeah, and I can continue. So I'm busy. All right. So let's move on. So let's talk about pgBadger and about analyzing Postgres logs like never before. So why do we, okay, what's going on here? Okay, what's going on? Am I in the wrong position here? Why it's not, why it does not like me? All right, I can move this one, okay. Okay, so why we love pgBadger? So first of all, anybody here uses pgBadger, knows what is it? Okay, 1, 2, okay, great. So why we love it? Why we love it? No volunteers. I love pgBadger, you know, like a person like many of us coming historically from Oracle, I miss the option to see what's going on in my database, because no information of what's going on inside Postgres is stored in Postgres. We only have logs, and reading logs in like sequential way is not fun. So pgBadger is the tool which is for Postgres but outside Postgres, and it gives us options, opportunities. Okay, let's trying to figure out why it's not working the way I want. Okay, sorry. And it allows us to see what's going on inside of database. So, all right, no, well. Okay, finally. Okay, so that is an example of standard pgBadger log, the way how we know pgBadger and used it for like many, many years. I want to say probably for like 20 years or even more. So you turn on full logging in your database, so you log everything which is going on, and then you process this log through pgBadger, and it gives you beautiful summary reports. So here is an example which is made, like generated from the real report. It's not production, it's staging, but still you can see what you can see. You can see how many queries were executed for the time you were logging. You can see how many distinct queries. It's always a shock, by the way. You know, you run like over more than 4 million queries, and Almost all of them are identical. Then you can see what was the total execution time and lots of details about traffic, how traffic changed through the time, and so on and so on. So that's what we love. But you know what I love more about pgBadger, and I think most people, that's what they love more. It's summary report about query execution. So let me show you. Why it does not go right way? Okay, so that is one of the last tabs of pgBadger. Those are reports about individual queries and how they contribute to overall performance and what is not. So one of the nice things there is the most time-consuming queries. So know the difference. It's not the most long-running queries, but most time-consuming. So they tell us the query might be actually relatively fast, but it executes so many times that it contributes most to the database performance or lack of it. So that's very important for the analysis. And then you can also run normalized slowest queries. Again, not necessarily the slowest query in the universe, but this type of query with different parameters in general is the slowest one. And then pgBadger gives you examples for each of them. So that is a great tool when you just know something is going wrong with the database, but you do not know where to start, you do not know which queries start to optimize, which processes to look at, etc. What is missing, or I would say was missing because things changed about a year ago. So for those who uses pgBadger, what you wish you had when you have all this beauty of all reports in the universe? So anybody want to have a say? What do I miss from pgBadger? Nothing? Okay, what do I miss? Which report? Yes, yes, exactly. That's what I was missing all the time. And that was like maybe, how can I make it possible so that I can see what this particular session was exactly my problem? The session, so one session, so user connects, opens the session, and that's like what this user is doing. So I will give you an example. So that's like a description of my open question. One of the pgBadger report is the most frequent queries. And you can see here, so you remember there were like 3 million, 3.5 million, and almost a million begins and almost a million commits. I would say it's here, right? But you do not know who does it. And you go to developers, say, hey, developers, why you have 1 million begins? And they're like, I don't know, like it's not from us, we do not know who is doing this. And you have like no proof, like, no, that's you doing, and you kind of think means in like gazillion of similar selects, they are doing something. By the way, who knows who are they? Who is doing that? Anybody knows who is doing that? Over there? Our best friend ORM, right? Yeah, these are generated queries, and there are ORMs which generate, begin, commit for anything, including selects. And by the way, like my new worst enemy is SQL alchemy, because by default, that's what they do. And they absolutely no need to do this. And developers do not know. So actually, you bring it to developers, like, no, it's not us. Like, I don't know where you got it. This, and this, and this, and that's where I see the problem. And I could not. And I was thinking for a very long time what to do with this, because I needed it. And I knew there should be an answer, right? I knew there should be an answer. We record this, so there should be a way to look at this log as a table. And when I found log foreign data wrappers, first I got, oh my gosh, that's what I need, because it actually creates foreign data wrapper to Postgres logs, and it maps it to the database, life is good. So when we install it, I found no, it's nothing good, because first of all, you can only do it for your database. Okay, you can theoretically move it to other database, but pretty much it analyzes the logs from your database. And also, it does not really parse, so it only parses the time and the session ID, and everything else is a blob. And what I'm going to do with this? So then I was like, okay, how I should do parsing? Because now, okay, say I do this log for in that rep, how I parse would. And then I started to think what I'm going to do. And then I thought about pgBadger again, because guess what? To run these reports, you need to parse the logs, otherwise you cannot parse it. And then I how I steal this parsing from pgBadger. And then I decided, why I have to steal? I actually need to ask Gilles Darrell, can he do this? And then, okay, how I approach Gilles? And then I ask my friend Leticia Avro, and she always brings me great ideas. And I was like, Leticia, I will introduce you to Gilles. But you know what? He's so shy, he might not even want to talk to you. Like, oh my gosh. So, I love to talk, right? If you did not know, you know now. I love to talk. She introduces us, and he's like, oh, yeah, it's so nice. I was looking forward to meet you. What I can do for you? I want the parsing. Okay, why? Because I want my reports. And he tell me which reports you need. I will make them for you. No. You don't understand. I want to make my own reports. Do you want to collaborate on this? And he went silent for 2 weeks, and I'm like, oh my gosh. She said he's shy, and I said something wrong. He does not like me, and it's the end of. And in 2.5 weeks, I received email, Katie, check my latest commit. All right. And if you think that was the end, and he gave me and life was happy, it was not. We had about a month of very intense debugging, because we found lots of things which he thought works, do not work. So we had lots of GitHub conversations, and my peers who knew that I'm interested in pgBadger, and they saw my name mentioned in every commit, they're like, Hetty, what are you doing? So then in about a month, we were ready, and we rolled out our new pgBadger magic, and that's what I'm going to present today. So now long storytelling is over, and now we will be talking about business. So I will describe the changes which were made. So when I first made this talk, they were relatively new. Now many people discovered that we have these changes. So many people started using it without even knowing why they are there. But I will describe the change. I describe how we are using it in DRW Holdings, and I will show some examples of practical implementation. I will describe how we do automation and what is next, because we are keeping working on this. So, first of all, new pgBadger features. So there were 2 features which were added and debugged, and they are even tagged now, so that's official pgBadger version. So one is a flag dump raw CSV. This flag produces parsed log in CSV format. So if you use pgBadger before you use it now, you know that your pgBadger generates HTML file, and it is somewhere on the internet where you put it, or it saves it in the local directory. So yes? Chocolate, that is me, because I'm all about chocolate. You do not know, now you know. I'm all about chocolate. No, that's an example. That's an example of the log. So the dump raw CSV, that is the flag, okay? And it creates the log, so the CSV log as an output. And second thing we did, we added CSV separator, because CSV by default is comma, and how many commas you have in SQL statement? A lot, okay? So default separator does not work. So we got this CSV separator, and now this last, okay, where is my, so this last line here is an example how to call pgBadger with these flags. So you call pgBadger, that is my log from my Swiss database, which is sitting there in this directory. And I do flags dump raw CSV, CSV separator $, and then I direct this log to chocolate CSV, and that is my file here, and I have the CSV log. So now, after I created this CSV, what I am doing with it? So now, watch here. It's magic, okay? So that's your log. And if anybody ever try to read log to find something, you know what the fun is to read this log, because everything is written in the order messages are received, so like 200 transactions, like intermittently. So now, CSV, right? And we load it into a table. And what's the excitement? You know now? Now you can do select, and you can select by any criteria, order how you want. Select means max, averages, whatever. So now all of a sudden you do not have this, oh my gosh, sequential file. You have a table which you can intelligently query and figure out anything what you want, what you need. So what we are doing with this table? First of all, we are doing session tracing. That first thing. You have PID, so you can select everything which the session is doing and give it to the user. That's what you are doing. Second thing, we can trace events which are happening at the same time, because now you can see, okay, this session was doing this session was doing this, and that's where they potentially collided. Also, you can do performance dynamics, because now you can not only do like, the longest, the fastest, the most frequent, but you can build whatever reports you want. You can do any analytics you want on these tables and compare how things evolve. So that's another great. And another thing which, like, I did not plan on it, but ended up being great, is precise access control, because I work in trading. It's highly regulated industry, and having users, passwords, all the security is not enough. We often have requirements to literally tell who touched this table, like, anytime. So that is a great tool to do this precise audit in terms of access control. All right, now design details. Again, what can be easier than CSV file? You take it and map it and no worries. Okay, so there are several things. So first of all, how you can uniquely identify a line in a log. There's no way, right? Nothing tells you that this line is unique, because a line is, okay, Postgres dumps whatever happened with the timestamp, and right. So the only way to do something with this, we need log ID, right? So just originally I set up log ID is a big serial, and you load, and each next record gets this unique log ID. So far so good. Almost immediately, like we said, okay, so log needs to be partitioned, probably. It will be a gigantic table. So first partitioning we did was so log sample is horrible name. I'm telling it for past 6 months, it's horrible name, but I still have it. It's actually the date when the log was recorded. But sorry, okay, bear with me. And then immediately we got problem, because we have this big serial which is consecutively assigned, and what happens if like we miss log file, right? We miss log file, oops, something got wrong with transmission, and we need to load this log file in the middle. Oops, we already have these IDs. So the only way to do this, we had to drop this whole partition and start loading from the very beginning. Okay, not cool. So then, okay. When we do reload, so same story. If we accidentally reload the log, there was no way to tell that we accidentally reloaded duplicates, because we cannot, because there is no uniqueness until we actually load. So that was another problem we had. And then we decided we will do something different. We will do further partitioning. So inside partitions by date, we are partitioning by list of log timestamp. So each log file, which is recorded in the log directory, has the timestamp when it was created, okay? And that's how we build the log ID now. So we are not doing big serial. We are doing this timestamp from the log, converted to epoch, multiplied by 10 in the 9th power, and then we do consecutive numbering of the records in this log. So what it gives us? It gives us, first of all, we still have incremental identifier. So the things which happened prior something, which will still happen prior something. So it's consistent. Then when we miss the file or we reload the file, we still can reload this file and it will get in the middle and we still have the correct order, right? So awesome. And we can reload the same file. It will be the same result. So we are not missing anything. So that was like a big design change and it works great. Then indexing. So first thing to what we're indexing. Primary key is like the obvious because we need, because we partition twice, we need log ID, so log sample, log timestamp. Okay, all good. Then obvious non-index fields, and that I get lots of questions from the users. Why you are not indexing by client by username? Because how many users are connecting to the database in the same time? Not that many. Even if people are creative and have like a couple of dozens of users, it's horrible index, right? Because it does not speed things up. So we're not indexing by that. Another non-obvious index is pattern search index. So we often want to find the query, which is something like that, has some table name, has like begin commit, what we just mentioned, and we need it to be like whatever case, uppercase, lowercase. And when I first try to index the query field by just lowercase of query, it said, nope, too much, I cannot do this, okay? And then we decided that we will index by first 1,000 symbols, which give us enough in most cases. And because we do not want the users who are looking at these logs to write this, because no send user will do this, so we are pre-building the search functions. So each user who works with their business unit, with their logs, got the search functions. They just can plug in SQL they're looking for, and this transformation happens inside the function. All right. So speaking about users and security, so we deploy our internal security model where each business unit has their own schema, and each table in the schema is a log from specific database. And we get read-only user, we keep track of process log files, and all the other things. So each of our internal customers have access to their logs and to nobody's else logs, though all of them are centrally like stored and centrally processed. Now, let's go to examples. Practical usage, so just wanted to mention that everything which I'm showing these logs, they obviously are not trading logs, they're like chocolate sweets and ice cream logs, but they are modeled from real life logs. Okay? So tracing sessions. Remember this one which I showed in the beginning, million begins, million commits, and so these users actually told me, no, we do not know who is doing this. And when I loaded their logs, I was able to do this. So first, where this begins coming from? So taking the log, counting, so finding sessions with the greatest number of begins, okay? And I run this query, and I receive a whole bunch of sessions which have like several thousand begins. So now I know the ID. I take one of these IDs, and then I'm running this query, and that's what I get. So now, okay, here user, that's what your session is doing. Begin, select, commit. Begin, select, commit. 10,000 times. Hello, user, go and fix it. I mean, it seems obvious why you would not know, but users were like, okay, thank you, that's new for us. We did not know. So now it's their problem to solve, but it's very easy to show. And I will show more examples like this. So that's like first obvious. I was happy that was no question. And since then, I started to do it almost a year ago. So since then, I'm still showing users what they are doing. And they're still surprised. All right, now other kind of problem, which is the worst one. So, you know, when you are like DBA, data architect, you get this question. You know, sometimes something is slow. And this sometimes is a killer. It's not like, every Sunday, every Monday morning, each time when we do, it's like sometimes this is slow and we cannot tell. Like sometimes yes, sometimes no, and go figure. Like, and they do not know what they're running. Just the database is slow. You get this, right? I get it a lot. The database is slow sometimes. Come and fix. So I started to approach it systematically. So we enabled full logging on this database and asked the users to tell us when it was normal and when it was slow. So they told us, okay, so there were these 2 days, and the first day on the 14th, it was normal, and for 17th, it was slow. And we went, first we ran this standard report, and so they told us when approximately they experienced slowness, so it was something like 3 a.m. And we knew that these were the queries which are executed like slow with like drop index. So we run the summary, and look what I see. So what I see that at like every hour between midnight and 5 a.m. on the 8th minute of the hour, they are running the same thing, right? So it's create index if not exist. So first of all, it's already alarming. Why you need to create the same index on the same table 5 times during the night on the 8th minute of the hour? So that was like super suspicious. But they said, no, that is okay, that is normal. But sometimes, like for example, 3 days later, it went so slow. I'm like, okay, let's see what is so slow. And the same query for 3 days later when something was so slow. So what we can see here, so first thing, here we see 5 lines, here we see 4 lines. And you know why? Because you can see that something which was running prior was so slow that it delayed the next execution. So it was not 2:08, it was 2:38. And then it like kind of rolled over the next execution, so the next was skipped. So, okay, something was going on wrong here. And okay, let's drill in, let's see what exactly was going on at this time. So something apparently started before 2:08 and became slow. So next query, we are looking at, here, let me go back. So here I also have the sessions ID, which were like fast or slow. Not fast, but okay, relatively fast. So now I am looking at what these sessions are doing. And they're doing something interesting. So first of all, we again have begins commits. And now look what we have. We have begin, then we have drop index, then we have alter table drop foreign key constraint, and then we have commit. So who knows why this happens, by the way? Who knows why people are doing this? Drop index, drop foreign key constraint. No, not this time, not ORM. No, this time I blame not updated school textbooks because, they're really not updated because, 40 years ago when I was at school, okay, 45 years ago when I was at school, and like 15, 20 years ago when my daughter was at school, the textbooks are the same and you students are coming, to work and telling the same thing. So you know what they're saying? When you do massive insert, you need to drop all indexes, all constraints to speed up this insert, and after this insert is done, you need to rebuild it. And it might make sense 40 years ago, but doesn't make any sense now. And by the way, they do not tell what massive load means, because if you already have a table with 100 million rows, and if you load new 500,000 rows, which is massive, so just go rebuild all these indices. They just take it because nobody told them otherwise. And they drop, so they want to load, they drop all indices, they drop foreign key constraints, they do the load, then they want to recreate indices and they want to recreate constraints, okay? And now they have begin commit, and that means that, let me see actually where I am. Okay, yes, okay. Double check. Okay, yeah, that's, no, that's the next one. Okay, so most interesting is you can see here that drop is not okay, create we think might have them, but why drop index and why drop foreign key constraint also takes long time. So obviously drop index because something is blocking, because there is another DDL on the same table running somewhere which blocks it. Then why foreign key altering table dropping foreign key constraint is blocking. So who knows why? Because I always forget it each time I rediscover it like it's a new thing. Okay, who knows why? Okay, so foreign keys are implemented in Postgres using internal triggers. And internal trigger is both on the child table and on the parent table. So when you want to drop foreign key constraint, it's like kind of 1 second exclusive lock on both tables, on child table and on parent table. And here, what happened? The parent table was used in multiple other cases for multiple other tables. And when I realized this, I decided to run this query to see what was going on at this time, which involved these processed file tables, and kind of could affect it. So just a brief description of what's happening here. Each load, they're loading different files, different tables. So each load starts from dropping everything, dropping indices, dropping foreign keys, inserting, creating indices, creating foreign key constraints. All of them are referencing the same parent table process files, because each time they want to load, they want to make sure that this file was actually there, delivered, and they can start loading. So that's why they go to this table, and everything is in transactions. So before you start another load, you need to make sure that the previous load done, and they created these indices and created foreign key constraints, because again, indices and foreign key constraints are within one transaction. So that caused just gigantic slowdown, and that was pretty cool, because if I would not have these logs in the table, I will never found this out, because it was very difficult to say that they're happening at the same time and what they're waiting for. It was technically loading to different tables. So that was like very interesting investigation, which would not be possible without it. So now, it's all cool, but so far, yeah, I'm not doing like process chocolate log or process ice cream log. We needed to do automation because like we needed to load these logs kind of in like centralized order. So what it takes to create this log table? We need to create a new schema and new read-only user monitoring tables each time we onboard a new business customer. Then for each new database, we need to create table, and for each day, we need to create partition, and then we need to start transferring logs to the pgBadger server. So again, I have a procedure which like tells, okay, so go to the schema suites and add one more partition to chocolate log for this date, August 8th. Okay. And then it's all good, but I did not update this slide. When I was doing this presentation first time, we had over 200 Postgres production databases. Now we have way over 300, I think like approaching 400 production databases. So we also needed to do some automation of all of this. So just having stored procedures was not enough. So one of our DBAs wrote like big Python program which does everything. So we could pass this program parameters, what is our new host, where we want, which pgBadger server we want to use, whether it's new or old, when we want to start logging, whether we need to turn parameters on, when we need to stop logging, whether we need to run it as a daemon, etc. So it's very convenient now because it's like one process and it verifies everything and it creates, calls the procedures, creates schemas, creates users, start processing logs, creates partition, and records everything in the monitoring tables. So that is super good, and it makes our job easy. We still do not do it for everybody, though it's huge demand, but we're still doing it kind of on demand. We turn it on sometimes for hours, sometimes for days. When we have a request, we need to investigate specific problem. There's a limited number of internal customers for which we do it like all the time. So by the numbers, again, this is this log which I demonstrated is generated from the real log, just substituting actual data with ice cream and chocolate. But this is not production, it's staging server. So this one was very small, so log size was, but just to give an idea. So log size was 2.2 gigabytes. That was login time 11.5 hours. So number of rows 3.5 million. Total size of the table 1 gigabyte, and that was loaded actually very fast, so I can tell that when we load now even very large logs, we are ahead of real time. So it's never like it's a block, and never we cannot process the real time load even with very large databases. So this process now is pretty fast. Now, a couple of things. So I wanted to have an example for this. I don't, because creating this log where I substitute everything from our business with ice cream and chocolate takes several hours. So sorry, I did not do this. I will do it next time. But it's something which I wanted to develop a while ago, and I did not, and now I have it. Okay, so time granularity. In the logs, if you do not do anything special, time is recorded as seconds. And you know there are lots of things which can happen with one database within a second, like too many, right? That's another parameter for the log prefix. If you want to record milliseconds, you need to put not T but M, and then it will be recording milliseconds. But you know what I found? That pgBadger was streaming milliseconds in this raw log output. So we again had this exchange of several commits back and forth with Gilles Darrell, and now the most recent pgBadger commit actually allows to load milliseconds. And now I can have, end time, so log time is when the execution ended, and I have duration, and I have this end in milliseconds. So now, if we have something like this, so start time is log time minus duration, and then for each record, I can attach the actual range when this query was executed, so from to. And this gives me the option to find what exactly was happening at this very moment. So the previous example, I was like, okay, I'm assuming that was at the same time, but now I can actually tell what was running at this very moment, okay? So now we are really powerful, because it really tells you what was happening and what was holding what. All right, so future work, more standardized reports, because now I need to show each and single business user how to do this. Then unit tests, I know, yeah, I need it. Archiving strategy, because again, we do not load them all the time now, but we need to have standardized archiving strategy so that only some of the old logs are kept and the others are archived. Also, having the link between standard pgBadger reports and these reports, because it's also needed. And wait events, I didn't do anything with this, but that's something I really want to collaborate with somebody to make sure that wait events are added. Look, there will be more, I think. I think it's an awesome way of doing this, and I think it's very much replicatable. So, where to find me? I'm everywhere on the internet, so, I am very loud. I talk a lot, and I am one of these people like, we do not have gender discrimination, but when a man is a strong leader, a woman is a fucking bitch, and that's me, right? So, but you can find me, but if for some reason you cannot find me, that's me. Okay, sorry. Actually, I apologize. Okay. So my LinkedIn here, my GitHub, I have 5 GitHub projects, like relatively small, but I like them all. Also, for Prairie Postgres, our new non-for-profit, so we support Postgres education in Illinois, primarily geared towards students and developers who do not know Postgres but still use it. So support us, connect with us. And the last important thing again, PG Day Chicago, April 25th. Registration is open. Please come, please join us. We will have tons of cool things. We have a great program. And I would love to see people there. All right? Yes?
So, as I understand it...
So actually, yeah, we can
Sorry,
officially
everybody.
open Q&A. Yeah.
If you have a question, let's put you on the mic. We are recording the room. All right? Thank you.
All right.
So in my understanding, as you mentioned, Oracle DB processes the query logs in the database, and then you can analyze them through there, right?
Yeah, it's not even processed logs, it records. So with Oracle, you have last week, if I'm not mistaken, worth of everything which is executed in the system tables.
And pgBadger, as I understand it, processes the log, and then you can export it, and then you can have to import it back into a Postgres database.
So yes, pgBadger does not connect to Postgres. So what we do with pgBadger, we give the logs, and pgBadger processes the logs. It's a program which is written in Perl, and it's not connected to Postgres. It only processes the logs.
Okay, so I wonder how difficult it would be to integrate pgBadger into Postgres to take the Oracle approach, because I don't really like having a log file that's bigger than the database, you know what I mean?
No, I mean, that will be effectively the case. I mean, there's Magnus here. You can ask Magnus what it will take to integrate it into the database. No, no, okay, no. That's okay. That's okay. Yeah. That's no. I mean, I do not think it will be feasible because yes, the log will be more than a database, and that will happen very soon. So again, we do not load log in the same database. Once again, we load it in the separate server. Mm-hmm.
Okay. Do we have more questions?
Right.
All right.
Okay.
Let's give a nice warm round of applause for Dr. Hattie for coming out. Thank you very much. Morning, everybody, and welcome back. We'll be starting in just a moment. quick PSA for everybody. I did ask for the temperature to be turned up.
Testing. Am I audible? It appears so. A couple more minutes.
Give everybody a chance to come in and get warm.
Yeah. Don't want to have them lose the opportunity.
All right, everybody with an HP laptop is feeling pretty warm. They've got overheating. Gotta love them.
Yeah. Yeah, my Lunar Lake Lenovo is not going to keep me warm at all. Stupid power sipping thing.
It's all about layers.
Now, I was pacing for like 10 solid minutes to try to warm myself up.
All right. Welcome back, everybody. This is Postgres at SCaLE 22. Our next talk is What's Your Vector, Victor, presented by Sean Thomas. Sean is a senior software engineer with pgEdge and will show us how to build rudimentary self-maintaining RAG application with just a few Postgres queries. We'll have time for questions at the end, so please hold on. I'll bring the microphone out to you. We are recording in the room, so we appreciate having the mic. Everybody, please welcome Sean.
Hi, everyone. I'd like to be the first to welcome you to the Arctic Circle. I hope you enjoy your time here. So this talk, hopefully you came here on purpose, will be about AI and Postgres. It's a topic someone may have heard of occasionally. It's been in the news a couple times, I guess. So if you're wondering about the title of my talk, I stole it from a very great movie called Airplane with Leslie Nielsen. I highly recommend it. I did not come up with that phrase myself because I'm not that creative. I work for a company named pgEdge. We basically do multi-master Postgres and some other stuff. We're an alternative in the space right now. We're kind of ramping up, doing our job. And I'm here on their behalf, but not for this topic. I am a kind of a community resource, essentially. I've been doing this stuff since 2005, on the conference circuit since 2011, and I've got a book. I need to write a new one because the old one's garbage. Please don't buy it or use it for anything. It's for Postgres 12, and Postgres 12 just died horribly, or at least it will in September. The information there's still relevant, but you know how fast stuff moves in tech. All right. So I'm going to answer some very rudimentary questions, and I'm sorry if I kind of annoy you with some introductory stuff. I've got to get us all on the same page. So I generated this with an AI, and I was running on my local computer because why not? And it's kind of an idea of what AI is perceived as, you know, our robot overlords, which I, for one, welcome. But at the same time, that's not really what AI is, at least not right now. It's more like this. This is what AI is. It's lots and lots of arrays, which we call vectors, and I'll get into that in a minute. And I'll have an actual example of one of these vectors later. Because they are a sight to behold. So I'm going to start by defining a few simple terminology sets, and we'll be on the same page. because I'm going to use some terms that are both amusing, enlightening, and related to Postgres. So, you've probably heard this term thrown around a lot. An LLM is a large language model. It is what drives most AI systems in the wild for either semantic search or AI chatbots or whatever have you. It's not the same ones that do the image generation or voice generation or movie generation or all the other ones out there. Large language models are the ones that you talk to and annoy yourself with. They're the ones that basically trick you into thinking they're human and could probably pass a Turing test if you really tried to do it hard enough. And they're the ones that are relevant to us and Postgres. RAG is retrieval augmented generation. This is the process of making LLMs not suck. As we may or may not know, LLMs are basically just big blobs of goo that are pulled from everywhere in the internet. Text that has basically trained them how to respond and classify and categorize things. But the compression method used to basically train the vectors is lossy. So they hallucinate a lot, right? RAG basically says, okay, ignore whatever you have in your information corpus, and instead use these articles I'm going to give you for your information generation. It basically, it doesn't entirely stop hallucinations, but it dramatically reduces them. And that is a technique that we're going to be using in this presentation. And I highly recommend it for if you were building any kind of AI-based system to use this approach. A token is essentially a word chunk. But in the LLM space, it's actually also kind of what represents a vector. I can take the word cat, take the word dog, I can turn it into catastrophe, categorization, whatever. There's a lot of different root stemming going on. But it also defines the surrounding information that token is nearby. So context is part of the whole process. Just kind of some examples of tokenization going on. Now, like I said, that's not entirely what's going on under the covers, but for now, that's all you really need to worry about. And embedding, oh, I didn't mean to put that in there. So, I did it again. Okay, so an embedding is a vector to token coordinates. So when you create a vector, you're actually creating, I don't know, we've all played with Cartesian plots, right? We've got an x-axis, a y-axis, maybe a z-axis. Embeddings are basically that times 1,000. It's very common for a vector to be at least 384 coordinates, and they commonly go to 1,000, 2,000 more coordinates. And basically, the amount of coordinates defines how accurate the LLM's classification system is, because it has all the contextual information, all the metadata essentially is located around that token vector. And I'll talk about that, how that works a little bit later. So where do these coordinates go exactly? I like to use this image because it's one, it's beautiful, but two, it kind of gets to the core of what an LLM vector coordinate is. So yes, I can, if I wanted to locate any specific fish in this, aquarium or wherever it's actually taken, I could give an X, Y, and Z coordinate and say that's that fish. In an LLM space, the coordinates actually say, okay, here's the position of it, here's all the metadata, like here's the school of fish it's from, here's the species, here's its coloring, here's where its fins were maybe pointed in which directions, however much data you decide to capture with that. Whether they were in a school that was running away from a predator, for example, like all of that is in that captured element. And that's why the vector coordinates are so long. I mean, you need thousands of coordinates to be able to say, okay, embed all of this pseudo information along that vector. And what you end up with in the end is a kind of a hologram, essentially. Because if I remove any bit of that, if I remove that third yellow fish from the corner, it slightly reduces the amount of context I have, but the image is still there. Like I know everything else about that fish that didn't get affected. So it's kind of beyond human brain's capacity because we're like maybe used to 3 or 4 coordinates, right? We can maybe like mentally break ourselves to go a little bit further than that, like 12 coordinates. But once you start getting into thousands or tens of thousands of coordinates, we're just like, I don't know what's going on anymore. So when people say they don't really know how LLMs work underneath the hood, that's why, because there's so much embedded information in there that you can't really track it anymore mentally. You can mathematically calculate it, though. So what I'm going to talk about is going to be how I'm going to turn Postgres into an LLM prodigy, essentially. And that comes with a few pieces. So I start with Postgres, your favorite database engine. That's why you're here, right? You're not in the MySQL room over there. You're in the Postgres room. It is warmer there. I'll admit that. And then pgVector. That's the extension that kind of does all the heavy lifting. It's added some things to Postgres, namely, we've got some vector similarity searches for semantic searching and matching for nearby coordinates. They've got different indexes they've added, operators to change how closely you want things to be related, like Gaussian distributions or whatever. It basically gives Postgres the tools it needs to properly and efficiently manage vector scale things and huge arrays of stuff. And it has been gotten a lot of press in the Postgres community lately because it really has made Postgres essentially an LLM vector database in a lot of ways. I haven't run any benchmarks against like literal, from the ground up vector databases, but I heard that that's comparable favorably to Postgres. So, but hey, you're already using Postgres, so why not use this? And then the final piece of the puzzle is pgVectorize. It is a extension for Postgres, because it can do that, written by the same people who I used to work for a few months ago, called Tembo. And it does a few things. It combines pgvector, which we love, pgmq, which is a queue system that is all in Postgres, right? So you can queue stuff into a table, and then you can have a watching process that pulls data out of the queue and then handles it. And then it has pgcron if you don't want to use the queue system, essentially. So when vectors come in, it doesn't process them right away with your insert statement. That would be dumb. There's no reason for it to do that. Instead, it goes, I'll queue the fact that I'm going to process this message later and then build the embeddings or process the vectors or whatever later. And then pgcron, so you can schedule stuff instead of doing that because nobody likes triggers, right? So I'm going to go over a few things that pgVectorize will do, like some of the built-in stuff that it puts on top of these 3 other extensions. So I can give it a model name, and then I can say my input string, and I can transform that into a vector, right? That's like the bare minimum it should be able to do. In this case, the encode function is actually using a transformer. I've got sentence transformer, mini LLM, version 12, whatever. There's thousands of these things, each of them with strengths and weaknesses over others. Some of them process technical content better. Some of them process, they're specialized transformers that will turn your text into a vector. And I just want to be clear, vectors are not sent to LLMs. We'll get to that in a minute. And then it can vectorize your entire table. So you basically give it a table name and a few attributes about the table and say, OK, vectorize the contents of this table. In this case, I took the author, title, and content of a blog table, for example. So now I can search any of those fields, and my embedding search will pull back content from those fields. And that'll let me do semantic searching, so I can look for felines. And even if I've never used the word feline in any of my content, it will find it because I've used cat 100,000 times, because I have cats, right? Because vectors And the way we like to talk about this is semantic search is it's the semantics. It's what you mean, not what you say, necessarily. So again, I just want to reiterate this. If you specify real time, like in the schedule down there, that will actually put a trigger on your table so that it will enqueue the fact that you've done an insert or an update for any of these fields here that I've modified for author, title, or content. And if any of those are modified, it'll regenerate the embedding vector for that information. But it won't do it live because, again, that would be dumb. Queue it so it happens asynchronously and that your inserts can speed along like they normally would. And here's where I would search semantically for the content that I'm looking for. Once I call vectorized table, I now have all of my content as searchable, so I can say if I have all my past blog articles from PG Friday, say I've categorized all those. Well, now I can search for, is Postgres the best database engine? Have I put that anywhere in my articles? Something like that. It will search the content. In this case, I want 5 results back. And it matches the vectors exactly, basically. It uses the same vectorization system as I've asked here. So it'll use this sentence transformer. It'll apply that sentence transformer to the query. Like it'll say, is Postgres the best database engine? It'll vectorize it using the same system. And then, since I've already have the embeddings for all my content in a table, it'll say, how close to any of those articles is that question? And it'll pull back the best results. I don't have to do anything. I don't have to rank my search terms. I don't have to put quotes around anything or minuses or any of that garbage. I just say, here's what I want, give it to me. And it does. And because it's always nice to have something in your toolbox, I can directly query an LLM and say, OK, LLM, forget all the RAG stuff, forget all my local content, just give me an answer. So say I want to categorize something or cache a response or something, then I can just talk to an LLM directly. And then I can just search again. Why do I have that? Is that really in there twice? It is. Well, forget that was there. All right. And then the other thing you can do is you can bootstrap a RAG stack. This is essentially just a wrapper for the vectorized table function, essentially. But you are telling pgVectorize specifically that you also want it to do RAG stuff. It adds a couple of extra things to the metadata, essentially. But in this case, I'm creating an agent that basically says when I use this agent name, I want you to do a RAG search instead of a regular embedding search. And what we know about RAG searches is it will pull back the article matches, and instead of returning them to me, it will send them to an LLM, and then the LLM will percolate and do its response based on those responses. That will affect the answer it gives, and then it will return the answer instead. So it removes a whole middle step to doing a RAG stack because it's all done in the Postgres layer. And this is actually what that request would look like as a RAG statement. I just say vectorize RAG, and then my question, right? The blog chat would be the agent that I created, and then the model that I'm asking. In this case, I'm asking a local model because Ollama lets you run LLMs locally. But I could just put OpenAI there and use OpenAI 01 or whatever one I want to use. I could put Claude in there. Anything that has a OpenAI compatible or VLLM compatible or Ollama compatible API can be used as an endpoint for this. So you could literally point it to anything practically, and it will act locally and give you responses back. So it just returns a JSON object, which you can you use for your own purposes. You can pull a specific field out, like I did in this case, the chat response field. And all you got to do to get this to work is, if you have an OpenAI, for example, is you just alter your system, set your API key to the API key. You can also pass it as one of the parameters to those search functions. Say you want to set one for your system and then overwrite it later. Or, like I said, say you don't want to use OpenAI, you can just override the URLs, and as long as you have an API compatible, you can say, okay, I want to use this instead. OpenAI is, they're stealing my data, they're selling it to the highest bidders, whatever. Now you don't have to worry about that because you've got Llama running locally, you can just send all your queries there and you never have to worry about it again. I actually did this myself before this demonstration. I've got an RTX 3090, right? 24 gigs of RAM for all your LLM needs. And I'm running a model on it. In this case, it was Llama 3.1 from Meta. Thank you. Sorry, Llama 3.1, not Llama. And then I just did everything there. No need to reach out to OpenAI. I don't even have a token. I don't know how to get one. So let's go a little bit into depth about how RAG works. Do you like my drawing? It basically comes in all these steps. So on the doc side, when I'm pulling in my data, I say I'm creating a blog. I gather all the content, do some parsing, put it into Postgres table, and then it's done. That part is done. That can be all done in this ETL process. That's easy stuff. The user side, I actually have to take the user's question, pass it through a transformer to get the vector, right? Compare the vector against the vectors I've stored, and then I take the vectors that come back from that in my app and say, okay, I've got these 5 answers from my source content, and then I attach the user question and say, okay, Mr. LLM, combine these things and give me a big answer in the end. So the app has to do all of this on its own. So there's a lot of back and forth between the database and the app and the LLM. It's just, so that's what's going on in this picture. The app layer has to do all the heavy lifting. And I actually wrote a blog on this where I did that with like a Python thing. And it was so much work, a little ridiculous comparatively. So that's what this whole looks like as one giant list of stuff. Here's all the parts we need. You've got to parse and load the content, generate the embeddings, transform user embeddings, get the results from the vectors, build a new prompt. And you've got to know the prompt format of the LLM you're interacting with, or it'll screw it up and it'll give you out of order responses. It'll misinterpret the question. It's ridiculous. And then you have to do all that every time the user asks a question, essentially. Or I can call 2 Postgres functions, right? I init rag on my content, and then anytime I want to do a rag search, I just say vectorize.rag. Done. So out of these two, which one would you rather do? All this or that? This, right? Or that? I know my answer. I'm not going to speak for you guys. So this essentially is what our rag output looks like now. Postgres is in the center, as it should be, right? So now Postgres gets the prompt, and it sends it to the LLM model, and it does the vector coordination, and all you need to do is send the question in. I don't have to send the results back to the app and have it rebuild the prompt and then send it back to Postgres and then no. I just say, okay, Postgres, send all this stuff to the LLM and give me an answer, right? And it does. Very, very convenient. So the other thing about doing this, and the reason I bring up using Llama all the time, is because it's an edge case, right? And I don't mean an edge case, a one-off thing. I mean, you can run your stuff on the edge, right? I'm a company called pgEdge, okay? And what that means is we don't want to rely on any external or centralized resource where that can be kind of like a bottleneck or a single source of failure or whatever. I have my database. My Postgres database is all over the world. I can just, get another sidecar or some kind of hardware that's got some GPUs in it, an NVIDIA A100 or something, and I can run Llama on that, and I can direct all of my all my Postgres queries to that system, and I never go out of my own little walled garden, not out of my VPN, it's all self-contained, and I can put that chunk of servers or whatever, that setup that I'm deploying, in Dubai, in the US, in Australia, and they'll all operate locally right there. And if you're using pgEdge, for example, to distribute your data in a multi-master setup, then all your vectors are calculated locally, or you can distribute the vectors all over your different systems, and they'll exchange, so you could parallelize your vector processing. But But either way, all of your results and requests are local. They don't have to reach out to any external systems to get their information. And that is a huge win if you're trying to get really rapid responses. So I'm going to go through the steps of building a sample RAG app. And it'll be very simple. So this is not normalized. Don't yell at me. It's just a big table where I put the entire blog. Like I'm not normalizing this at all. Okay. And then here's something you may not know about LLMs and embeddings and vectors. The smaller the transformers that handle your smaller questions are very lossy because they only have 384 coordinates, or maybe 512 or 1024. So you need to break your content into chunks. Easy way to do it is just break it into paragraphs, right? There's a little more complicated thing in there, but basically, your whole article can talk about a dozen things by the time you're at the end, and it kind of makes it hard to categorize what the content's actually about. So you break it into smaller chunks, like 1 or 2 paragraphs each, and then that gives the vector, the transformer, a little better accuracy as to what content it's pulling and matching against. So for my particular blog post here, this is what it looks like. This is the exact query I used to vectorize my blog chunks. And notice that I used the chunk table and not the article table, right? So it's article chunks. And then this is the text splitter I used. It's just a Python thing. It splits on new lines and periods and 3 backticks because there's lots of code samples in the stuff I write. Nothing really crazy here. And if you ever play with Python, Postgres, LLM things, LangChain is a very, very popular library. They have a ton of tools for doing stuff like this. So these are the tables, how they look in Postgres. And then if you wonder where your embeddings are, they're actually in a separate table in the vectorized schema. So in this case, it adds a underscore embeddings, and then the blog chat is the name of the RAG thing that I created. But that way, you don't have to encumber your data with these several thousand long vector, arrays. It's in a separate table. It'll key into it, like the table looks like this. So it's got the chunk ID. It knows from your article information how to do to pull the same ID from your chunks, but it's a separate table. You could drop it and then just forget about all this embedding stuff and go on your merry way. It's not a big deal. And it also has a couple triggers because I used real time, right? Because I wanted real-time embeddings to be generated as I'm inserting or updating data. So I'll have to talk to the author about this, ask him why he did 2 triggers instead of 1, like because before insert or update would probably have been sufficient. There's probably some internal reason he did. But that's the other thing, is since I know the guy, I worked with him, I can be like, so why did you do this? Like, could we maybe talk about some of these things? And then let's talk about how this kind of works, because you'll notice this vectorize handle update blog chat. That's the function that this trigger calls. Well, in that trigger, it has this statement to call another function that's less, because notice this one is basically named after my blog chat, so it's basically a trigger that is made specifically for this table. Well, it calls a generic handler for these things called underscore handle table update. And in that function, we'll see that it's a C function that has source code that it's an external call essentially, which means I had to go to the Rust code for pgvectorize, and then in doing so, I found this statement. For that particular function, it uses this query. Remember when I said it queues when you do your insert or update? Well, that's where it happens. There's like it does some prep statement to kind of prepare all the the parameters and content into a properly formed JSON object, but at the very end, it does that. So it queues the thing you're trying to insert or update, and then it gets vectorized later. And if you're ever wondering what's in the queue, it's a lot of stuff. It's just it is a JSON blob of the all the fields in your table, the chunks that's being processed, all the stuff that it needs to its own internal bookkeeping. I didn't put that on the slide because it would have filled 2 or 3 slides, even if I made it like 8-point font. But if you're ever curious to follow this experiment and you do the same thing, you can kind of look at it under the hood. And that's what a vector looks like, by the way. That's a vector of one of my article content chunks. It's pretty much meaningless garbage, but that's what pgBadger is for. So, right? That's why I said it looks like that, because that's pretty much literally what it is. So now, when I do my vectorized RAG search, that's the response. Is Postgres the best database? And then it says, and this is literally what I said in one of my articles, since 2017, Postgres has won Database of the Year award, blah, blah, blah. And it rephrased it. That's how you know an LLM was involved. Like, it took my statement from the results and it said, okay, well, how can I rephrase this to be a statement of fact saying that Postgres is the best database? And it did. And if I did this without RAG, like if I didn't use RAG, if I used the generate to compare the vectors, if I just use generate to ask the LLM directly without using RAG, this is what it said. Because it's a non-committal, it's, whether it's the best database, who knows really, it's just going to waffle on. So I made it definitive by using my content as a resource instead of whatever was built into it. That's how you know it's working. So what do I consider an advanced technique? So what are the weaknesses of using this approach? So what if I want to ask the LLM how window functions work? That's a little more technical of a question, okay? And this particular thing I'm actually pulling out because the field you get back from vectorized RAG is it also tells you the chunks or the matches that it used to send to the LLM. You can get that content if you ask for it, and that's what I did here in this query. So these are the articles that came back, right? They're kind of off topic. And if you'll notice that second chunk, what happened there? My chunker needs some work. Clearly that little text snippet wasn't very relevant, but it came up in the search anyway, because it has the word window function in it. What I really want to do is have an LLM rewrite my prompt, okay? Because I'm saying, Mr. LLM, I'm using a RAG app, okay? Please take my prompt, that user prompt right there, and rewrite it using these restrictions, okay? My chunks are less than 1,024 bytes, tokens in this case. Basically, I'm giving it rules to say, give me some kind of better search terms I can use that will match with the transformer better. Because the transformer has certain restrictions, right? It has strengths and weaknesses. So it came up with this. The LLM said, okay, I understand you're using a transformer and you're doing a vector RAG search. Here are the terms that I'll have you search. You should search for these instead. These will give you better matches against your corpus, because that's what the vectors would point to. So when the transformer vectorizes Postgres window function definition, it'll get me a slightly different variant of the vector, which may be a better match against my content. And these are the articles that brought back that time. So you'll notice it's a little more specific. Like I'm talking about how window functions actually work internally, and I talk about their actual functionality instead of just the word window function. There's more there. And then you can point that into RAG and get a better response even from the LLM, and because it's working in more authoritative sources. So in conclusion, using all of this with my babbling, you can essentially write a Postgres app. You can write an LLM RAG app if you can write Postgres queries. And who here can't write Postgres queries, right? And I will now open the floor to questions. A little bit early. I was 3 minutes faster than I should have been.
No, perfect.
Looks great. I see you said Rust.
Yeah.
Are you using PGRX?
Yeah, so this
extension?
particular extension was written by a guy named Chuck, Adam Handel. He wrote pgMQ and he wrote pgVectorize, and he's got a couple of other extensions under his belt. But he works at Tembo currently still, and he wrote a lot of this stuff in Rust, and he is using pgrx for it. So yeah, you can thank Eric for that. The pgrx project is great for this kind of thing. But yeah, I mean, there's a very active repo. So if you go on GitHub and look at it, there's a lot of stuff going on there. And there's some changes that he wants to add, like he wants to be able to do like what I talked about there, the augmented RAG search, where I can have it do a preliminary, like modify my vector and give it a better vector search, and then use that instead, for example, so I can have like intermediate steps and get more fine-tuned responses. But there's stuff on the field coming in.
Just another question, quick.
Yeah.
What will be the difference between your approach and pgML, for example, that also uses pgrx?
I don't know much about pgML. Sorry.
You showed a few different models in the examples.
Yep.
Do those models need to be installed on the machine that runs it, or does it use the API to?
Yeah, so what it comes down to, if I can get to this, okay, so it really just boils down to this guy here. So because you're specifying the API endpoints, you're basically saying, yes, you could run it locally on that machine. I wouldn't recommend it because Postgres and LLMs are doing different workloads, so they'll need different hardware behind them. But in this particular case, my desktop was running this LLM server and the transformer server, and then my Postgres server was in a server in my basement. I've got a couple of R730s in my basement, some power edges for doing experiments and cluster work. That's where my Postgres was running, and it was contacting my desktop to get API responses back. So, like, I cobbled together some janky duct tape and baling wire thing in my basement that it can do this. So if you have more high quality resources available to you, you can. But you don't have to, right? The point is you've got some flexibility here. Where you run the LLM API front end doesn't really matter as much as is it running at all.
And do you need a GPU? You don't need a GPU to run this if you already have the models, right? But if you want to
the
train
GPU
your
just
own
makes it
model.
faster. You can run models literally anywhere. Like if you open Llama Llama will run, Llama 3.1 72 billion vector version, which is a 30 gigabyte file. It'll run it. It won't be fast if you don't have a GPU, but it'll run it.
It will take hours or days.
I mean, I think the token generation rate from a CPU is like 8 tokens a second on that model. So it's not fast. But with the GPU, it's like 100.
Thank you very much.
Yeah. Next.
Thank you very much. It was a great presentation. I'm curious about, I have a lot of questions, but the first one that really is, what if I have multiple tables that I want to join together? Is that possible to use this or make a view out of it?
So I haven't experimented with this, but you might be able to create a view and then vectorize the view. Because like I said, it's storing the embeddings, which are the important part, in a separate table. So what I would do is, I'll have to check to see if this works, but it should, is do the init rag on the view, and then those fields, like when you list the columns you're trying to have it embed. Yeah, so in this case the column is article, but you could easily just concatenate like 3 columns from your view, or just make the view do it on its own.
Yeah, that makes sense. Just also, does it sort of take care of updates? Like if you're updating the data, the system will actually recode something? I'm just not sure how that works. If you want to update like if it's a review system and the reviews are updating, something like that, how does the system, does it do it live? Is it always just doing a live search?
So yeah, so in this case, I put the real time in the schedule, which basically it puts triggers on the tables underneath it. If you did a view, you'd probably have to use pgcron instead and put it on a schedule. But what it normally would do is anytime an insert or an update comes into this table to your content, if it affects the field that you're watching, it'll basically regenerate the embedding.
Got it. Well, last thing, I'm just curious about how this might compare to other systems like Pinecone, Weaviate, et cetera. I mean, you may not know, but.
Yeah, I'm not in that space enough. All I saw that there's a really easy to use extension in Postgres, and I'm like, oh, I can run 2 queries and I can make a RAG app. That's awesome. Like, cause I did this in Python initially without using pgvectorize, and it literally took me like 200 or 300 lines of code just to get the back and forth to the to the LLM and everything working properly. I had to like figure out what prompt format my LLM was using. I had to like reproduce everything from scratch. But in this, like I ran 2 queries. So I was like, and actually in my blogs, in PG Friday, I did a before and after, okay? I did a before where it was just like all the Python, and I've got a GitHub repo for it too. And then after, I'm like, here's the same thing, but just using this vectorized extension instead, and it cut way down on the code.
Hey, thanks for a great talk. If I wanted to work with data where the Postgres has a reference to, say, audio or image files that are stored elsewhere, would you need a new custom PG extension, or do you know if that's the kind of problem that's been solved for creating embeddings on things that don't live natively in the
Yeah, that's a good question. Like anything where you had to pull the content like externally through Postgres to have it processed further, you'd probably have to do it with a foreign data wrapper so that it could kind of pull that remote content as a field instead, or if you're using blobs, which I don't recommend, to store it in the database itself. Yeah. Like if you're storing like file paths or something, you'd probably need to find some other way to feed it in. And I don't think that's something pgvectorize can do right now. But like I said, Adam Handel, great guy, always working on this stuff. If there's some way he can add that, like without causing too much weird, gyrations or overhead, or he's open to suggestions. So,
thanks.
Thank you so much. I have a question on some of the search things, like how much, do you know like what it's doing? Is it just doing like a cosine similarity, or is it doing some other full text search things?
That's a good question.
Can we tune it? It was 1, and 2 was, I forgot what 2 was, so that one.
Yeah, so as far as how it's doing the search, I didn't list all the parameters here. So for like when you're doing a RAG search, for example, when you've got this guy, you can, I'm pretty sure you can specify where clauses to kind of cut down on the result sets that it's, there's like a where, and you can use that as a parameter to feed it where clauses in addition to whatever it's doing on the RAG side. As far as what operator it's using as kind of like which kind of similarity search it's doing under the hood, I think you can override it, but I would have to double check. If not, then that would be probably something that you could have Adam add again, because how it's doing the similarity search will definitely affect what results it's producing.
Right, yeah. Because in the RAG world, like, they did all vector stuff, and then they realized, oh,
yeah, because
we've got some of the full text search.
We've got all these operators, right? So
yeah.
Which one is it using? I don't really know.
And then when you do the full RAG, right, so you grab the things and then you do send them to your LLM. Is the prompt stored in there somewhere? Is that a magic prompt?
I think that comes back in the response, because like that JSON object, it shows you the relevant documents that it fetched and sent to the LLM. It also uses the original user prompt that it sent to the LLM. And I think, but I'm not certain, that it also has a field for the prompt in that JSON output that says, here's the prompt I sent to the LLM.
Okay. I was just wondering if that was like another thing you set in your, when we were setting the URLs and the keys, and if there was tuning for prompts.
Yeah, and see, if you
Cool.
don't want to use the RAG function, you can do these steps manually, right? Because we've got this other thing here where you can say, okay, well, I can do I can encode my question myself, or I can do a search and bring back the results directly, and I can build my own prompt to the LLM, and then I can use generate and just send the prompt directly, right? I can make and it's still like 3 or 4 Postgres functions. You don't have to do like any like crazy back and forth stuff to an app. You can just say like, well, I run a query into a query into a query, use a CTE, right? And then just build all the query parts, have it generate the prompt, and fork it into the LLM. Yeah.
So what about integrating with multimodal models, like text and images? Not text, but images and audio?
I don't know.
Not yet?
So the whole, this extension is, I wouldn't say very simplified, but it is a particular niche. It's generally for text. I know that Adam has done a lot of work in this area as far as AI and LLMs and whatever are involved. Multimodal content would probably be based on how your content is encoded into your vector columns. Actually, not even vector columns, like when you, because the article content, I was using title, body, whatever. The chunks that I have in my article table could be anything. So these chunks here, that chunk column could be an image, or it can be an audio file, or it can be a video. Now, I'm not usually one for putting that kind of content in a database because, you know, that's not really what it's for. Databases aren't file systems. But at the same time, if you want to produce vectors for stuff like this, that might be your only option. But at the same time, pgVector doesn't care. The transformers don't care. So if you can find a transformer that's good for, you know, videos or images or audio or whatever, you'd use that for encoding your chunks, and then it would match the same way it does now. It would just, you know, the content wouldn't be a text thing you could send back to an LLM because it's, you can't really send it a video binary bit, I would assume.
Couldn't this just be like, you build your own Shazam in a way? You could transform the audio into a vector and back.
Maybe.
Sorry, Sean, would you mind repeating the question?
Yeah, so could you build your own like Shazam? Would be the question, and you can build your own anything really if you really want to. Like I saw a talk at PASS fairly recently where they took the responses from the RAG output and cached it in a Redis layer, so that if you got a question from a user and it matched they hashed the question essentially after they put the question through an LLM and had the LLM produce a hash essentially of what the generalized version of the question is. And now if anyone asks a question like that, it comes from the cache instead of the LLM. So they've just added a whole shortcut to the system. So like for their chatbot, if you want to build a chatbot, for example, you can add intermediate steps to have it just cut out the middleman. Stuff like that, this can't really do by itself. You'd have to add, you know, harnessing or triggers or callbacks. But again, this is a really new extension. It's only been around for a little over a year. So the fact that it does any of this at all, I was kind of shocked when I first found it. Any version that supports pgVector, it will work with this. Yeah, sorry, with the microphone.
Oh yeah, quick question on, suppose I want to have some lower level control on details of the vectors that pgVector exposes, such as, you know, exact dimension or scalar quantization. Are those, you know, is tunability of those things exposed in the params for pgVectorize?
No, but it's highly dependent on which transformer you're using. The transformer I used was always producing 384 coordinate vectors. So if I picked you know, one of those small LLM, small transformers from OpenAI, they've got a couple of transformers that produce 2048 vector embeddings. If I used that instead, I would have had to, because it knows what the output would be, and it would always, because the problem with pgVector is you have to define the size of your vector beforehand. So part of this is if you change your transformer sometime later, say you're tired of this transformer, you want to change it, you can, but then you have to regenerate all of your embeddings because the embeddings have to be the same transformer for them to work properly.
Okay. Any other questions? No? Perfect.
Going once, Bueller?
We got one more. Do you mind?
Well, I'll take one more. I'll take as many as you got.
Sean, do you mind if I just make an announcement about the birds of a feather thing?
Yeah, sure.
Okay, so tonight here at 6:30, we're going to have a birds of a feather meetup for anybody who is interested in search or analytics. That's full text search, vector search, kind of analytics queries on Postgres or anything like that. 6:30 right here. Thanks.
6:30?
6:30.
Okay.
All right.
And now
Hope you
everybody,
enjoy the rest of the conference.
let's thank Sean for coming up, speaking. Thank you.
Ow.
and then your coworker did leave some
Let's try. Hello, hello. Working.
Be starting in just a couple of minutes.
It is.
Okay, welcome back everyone. We are back, SCaLE 22. This is Postgres at SCaLE. Our next talk is Anatomy of Table Level Locks in Postgres, presented by Gulcin Yildirim Jelinek and Andrew Ferries. Gulcin is a staff database engineer and Andrew a staff software engineer, both working with Zeta. In their talk today, they will help us all gain insights needed to perform efficient schema changes. We will take questions at the end of the talk, but please wait for your question until you have the microphone, since we are being video and recorded. Please welcome Gulcin and Andrew.
Thanks. Hello, welcome. Does everybody hear me well? Okay. So today we will talk about anatomy of table level locks and what kind of strategies that can help us while we do the schema migrations in production. And I was already introduced. I work at Zeta. I'm also quite active in the Postgres community. I live in Prague, and this is my first time in US. Very excited, and it's really going well so far, so thanks everybody who is organizing the conference. It's really good. Okay, and Andrew, I will also introduce Andrew. He's my colleague, and we divided the talk to two parts. I will talk the first part, and then Andrew will introduce PG role, and he will do also a demo. So what is in the agenda? We will talk about MECC design and how the DDL logs work, and what are the types of them, how the log queue in the Postgres works, and what can we do, what kind of things we can do to reduce the logging impact and log contention in Postgres. And then we will introduce this open source tool that we are developing in the company that we are both working for, and we'll do a demo. Okay, so let's start with logging in theory. And I am a person, when I think about a concept, I go to deeper in the etymology, like where it is coming from. So I went into deep with the logging. So I ordered books about, I don't know, log picking, Persian logs, history of logs and stuff, to kind of understand the logging in general. But as you probably guessed, logging in real life is mostly about security. And in Postgres, it's nothing to do with security. It's most about a concept that Postgres handles for concurrency. And this is what it is. But there's one thing now that I have these books, I can actually draw some parallels in between. To be able to pick a log, you need to understand how its inner mechanisms, how they interact, how the tumbler works with it, how can you actually position something that you can unlock without even using a key, and to be able to, I think, understand any system in a deep way, then you don't really need to, you don't need to understand logging, but if you know concurrency, you will kind of grasp this mechanism as well. So you can open the safe without a key. If you understand concurrency in Postgres, you will also understand how the logging works and what is the intention. Okay, so as I said, how do we handle concurrency in Postgres? Mainly, we have this system called multi-version concurrency control. It is not something specific to Postgres. A lot of databases actually incorporate this design, and lots of other software as well. And this actually helps us with the many logging issues that is associated with databases. How does it work? When instead of modifying the rows in place, each time when we have an operation, we are writing the new copies of the rows. So Postgres is having a new copy of the same log, different rows, and same data has in the multiple versions. That's why there is multi-version in the name. And thanks to this approach, we know that reads don't block writes and writes don't block reads. So this is really good for Postgres. That is a really efficient way of handling concurrent YAML operations. So instead of modifying the data as in the place, so we actually, by doing lots of copies, we allow reads and writes to continue in the high concurrent environment. But even in a system with an MECC-based system, we still have to have some level of locking that we can't avoid. So we might, reads may not block writes, but they will still acquire lightweight locks on the database objects like tables and views and types and so on. And there's another thing to know. Different variations of the command, let's say an alter table command, they will have a different level of locks. So you will not get one alter command will not give you each time the same level of locking. So that kind of makes things more intricate. And you will have to kind of arrange your queries in a way that trying to avoid getting the most restrictive locks. And that will be the topic of today's talk, how we can actually do that. I prepared an example to illustrate to you how actually MECC works. And as I said previously, when a transaction is updating a data, Postgres is creating a new version of the row, and it still keeps the old version. And each of these row versions contain system columns that are not visible to users, but it's crucial for MECC. There are many, but I think if you know two of them, that's really important. The first one is called xmin. This is the transaction ID that creates the version that we are looking. And the xmax is the transaction ID that deletes or updates this version. And if it's the current one that is at the moment that we are looking, that is usually null. And there are more, there's cmin and cmax for command IDs within the transaction. And there is CT ID, that's the physical location of the row version that we are looking. So, and also this example, is representing the default transaction isolation level in Postgres that is called read committed. So if you will do this example in different transaction isolation level, you wouldn't get the same results. So be aware. This is what will I explain is only for the Postgres' default behavior. So what do we do here? It's super simple. So there is the first row. There is a single row, and we see Alice's salary at 50,000. And that is the transaction ID on the left, the first transaction, is transaction ID 100. So it's starting, and it gets a snapshot for its select statement, and it sees Alice's salary at 50,000. And because the row's xmax is null, we know that this is the current one. And also the row's xmin is 99, if you could see it like next to the salary, that is the xmin. It is less than our transaction ID, which is 100. So we know that this transaction 99 is already committed. And then the middle block, middle column, this is representing the second transaction. The transaction ID is 101. And it is updating the salary to 60,000. And once we are trying to update this data, normally, like if we were not using the MSCC, we would update the salary already. But what we do is that we are creating another version. So we have 2 row versions now. An old version is marked with the xmax, that is the transaction ID that is actually doing this operation. And we are creating a new version with an xmin with this transaction ID that's 101. So once the second transaction commits, that will make the changes visible to any new snapshot that will happen. But before that, I wanted to show the example again. In the first transaction, it is executing another select before the transaction 2 commits. It will still see the salary 50,000 because now at this point transaction 101 didn't commit yet. And once the transaction 2 commits, and then when the transaction 1 executes the third select, the last select, this time it will see the 60,000. Because now this is committed, and each statement that is even in the same transaction, it will see the committed changes. Basically, this is how it works. It's like simple, but it, I think, explains it. We can see that 101 is the xmin is 101, and the current version xmax is null. We can see that. The old version with the marked is with xmax 101 means that it will no longer visible to the new snapshot. Isn't the case with 50,000 the salary? We will not see this anymore. So that's why when we had the third select, we didn't see anymore that 50,000, and we get 60,000. So as you can see, this behavior is like helping, but of course, with every choice, we have some implications that come with it. One of the easy ones to see, since we are adding rows, and there is some accumulation happening, so that rows being accumulated until any vacuum operation cleanses. So that brings us to an important topic in Postgres. We have to make sure that this setting for vacuum settings are good. We have a regular maintenance, so these things are important for the Postgres performance. But again, to finish up with the clear benefits of MSCC, this is important because now Postgres provides consistent snapshots, so we can actually continue reading while writes are happening. Okay. And why do we log? Because if you have, let's say, MSCC, and maybe we don't really need to log, we have to, when we think about logging, is in itself, like whatever type that is, it will reduce the throughput for sure. It will potentially increase the latency, and that means a loss of performance. So ideally, if we try to avoid logging, but we have to do this because if you want to make sure that your data doesn't have corruption and everyone is getting a correct result the time of their query, so we have to agree to the standard. That's why we have this transaction isolation levels in Postgres. So we have to follow the standard to keep things actually consistent and providing correct data. And of course, we can't keep a log too long. This also has the consequences. So database management in this way has to have some sort of balance. We need to make sure that we can serve multiple users at the same time, but we have to accept a level of isolation once we do that. And there are different levels, so you can check it, what Postgres actually is offering in this terms. Okay, but today we mainly will talk about the DDL operations because most of the DDL operations require stronger logs because those are the ones that are point of interest for us. And that means that they are potentially blocking other operations. That means that they can actually block other DDL commands, DML operations that are happening, or even select queries. And the implication of it that basically you can block all access to your database while you are trying to do the schema changes. And that's why I think it's important to understand what kind of things can go wrong. And as I said before, even some of the subcommands can get different level of, can acquire different level of logs. That's why we have to understand how they interfere with each other, how they work together, and what we can actually cause while we are having schema modifications in a busy database. Okay, we divided the talk with small takeaways. I think it's important because it's a big presentation, and if you will take few things, we gave like, I think 6 of these items, so you can just take these items with you, and it will be already quite helpful in my opinion. So the takeaway first is like, as we discussed, MECC makes Postgres very efficient, highly efficient for the concurrent DML operations. So we don't modify data in place, and we just create new copies of data that will allow writes and reads happening without blocking each other. But we should be aware that same DDL commands get different logs and varying different logs of strength. Okay, so what are these logs? Let's look at it quickly to see what they are. And this is not an extensive list. This is definitely not an extensive list of what commands get what type of log, but it is easy to look at it from the documentation. But here, this table, I marked it with white and purple. The more you go down, the more restrictive it gets. So the access exclusive is the strongest log. And this can be used by operations like drop table, truncate, or certain alter table commands, and vacuum full. And since this is the most restrictive, it blocks all concurrent access to your database, and is unfortunately required for most of the schema modifications. And the least restrictive one, the most basic log, is on the top. That is called access share, and this is used by select operations. Multiple transactions can actually hold this log simultaneously, and then the more you go down, this kind of gets more restrictive. So there's row share, which is like used for like select for update, select for share. It's usually compatible with most of the other logs, except exclusive logs, of course. And for DML operations, we get row exclusive. Those are like insert, update, delete, merge, all this DML. And then we get for maintenance operations like vacuum and analyze, share update exclusive. And this conflicts with almost everything as well. And for creating index, we get share. For creating triggers, we get share row exclusive, and so on. I think it's important, like, which operation gets what log, but more important is that this can be easily checked, but what is important, in my opinion, is how these log modes interact with each other. There is a matrix in the Postgres documentation. You can see how this actually interfere with each other. I think that's more important, that matrix, because when you take this, acquire this log, you might block, you might conflict with another log that you might not know if you didn't check this table before. Or you can actually query those, of course. You will see based on the system queries as well. And so what is to take from this slide? I think it's very important that we need to know with access exclusive, it conflicts with everything. So your selects are not safe either. And normally Postgres has a lot of optimizations to take the weaker log modes if it can, but it's like nothing is perfect. Sometimes you have to take the strong logs on the DDL operations. And another important thing is that once a transaction takes a strong log, and it holds it even though statements can finish. And we will talk about this more because I think it's very important. And that's why I added in the takeaway too. Maybe you wouldn't think that this will happen, but once the transaction acquired the log, it will be for all entire transaction amount. So that is very risky, and people actually fall for this a lot. And my recommendation here is that you have to separate statements, that if you are doing, let's say, alteration command is running, and also doing like manipulation, they are updating some stuff, separate those, because you don't want to, let's say, instead of getting row exclusive, you don't need to have an access exclusive for the whole transaction. It's like bad. If you can separate these things, separate them in different transactions, so you don't actually unnecessarily keep a most restrictive log because you combine them with an alter. Okay, so how we can't talk about Postgres logs without talking about Postgres log queue, how it works. So when a transaction requested a log that conflicts with an already another log that was already held by a different transaction. As I said in the matrix that I was mentioning, you can see those ones. So they enter a log queue. And by default, this one is tricky. This requesting transaction that's trying to acquire the log will wait indefinitely. If you didn't set log timeout, it will be just waiting for that transaction that is already acquired the log. So we will be waiting for this. And these logs all will form a queue. And there's also another unfortunate thing that you can't really see these things in the PG logs view. And instead, you can use PG blocking PIDs function to identify which actual backends are blocking which specific backend. And there's another thing that the logs that are ahead in the queue can block the logs that are behind them. So we will have this cascading accumulated waiting event, and that's not really nice. So the takeaway that comes after this discussion, it's really important to set log timeout. And I think if you set log timeout for only DDL, you're already in an advantage. Because you probably, like for DDLs, right, either some system or some maybe operator, database admin, or sysadmin, or whatever automation tool that you are using, you know the timing of the migrations. It is not something that's through, like, I don't know, a standard user of an app. They do selects and updates, maybe data manipulation, but they rarely probably trigger some DDL operation. So that's why if you just set the log timeout for this DDL specific operations, you're already good. And because that doesn't come without a price, right? If you set a log timeout, there will be things that are affected from this timeout, and then you will get errors, and most of the applications are not really handling what comes from databases, always like causing, like what's happening, I don't know what's happening, and so it will propagate. And that's why if you are setting this log timeout, you should also think about how will I handle this if this timeout is applied, so you will have to have some mechanisms to retry and gracefully give errors to people. So like you need to roll back or retry or something, and you need to some mechanisms. And yeah, this is important, and we will talk about it later in the PG role as well, why actually we set log timeout already. And the queue, I think the example here is making things more easy to understand, at least for me. I was thinking it is much more easier to understand with the commands. Let's imagine we have a select. That's a simple select. People think that is an innocent operation. Nothing can go wrong with long-running select, but it is. So in Postgres, any type of long-running transaction, it is then something to look for. Like you can't let things run for a long, long time. Why? It is because of this. I took this example from a production issue that caused a long downtime for a very big company that is known by everybody. So there is a select running, and it actually has a very simple, the least restrictive log that you can take, access share log. And then somebody was trying to run alter table detach partition, and this actually needs a brief access exclusive log. But they conflict. So this alter needs to wait for the select that is being held by this needs an access. They conflict with each other, so it goes back. And then let's imagine there's another like 30 or 100, depends on your size. There are different backends that are trying to do some select as well. And this also conflict. So they're all conflicted with each other, and then basically they all put behind the log queue, and what happens? Basically all this access is blocked now, and until both this select finishes and the alter finishes, all the things that are coming after will have to wait. And basically that's why I'm saying that it's important to set the log timeout, because if it was set here, this wouldn't happen. I mean, it's an easy way out from this. But again, your applications, of course, must be prepared for it to handle these failures gracefully, and you need to implement some sort of retry logic for the operations that time out. OK. And this is the takeaway 4. As you've seen, the simple, looking very innocent SQL select caused this issue. And that's why any long-running query is important, that you have to probably check for this. You have to monitor this. You might not expect it, but when you are doing schema modification, this is something that really needs to be checked before. OK, so far we talked what things can go wrong, but we decided to design this talk to how to actually help you guys or help everybody who comes to this talk. So when making schema changes and running maintenance tasks, it's crucial that you have to minimize locking to avoid blocking other queries. So we will try to get the least restrictive lock as much as we can. And there are like multiple things we can do for it. For example, this concurrently command in Postgres. If there is a statement that has already concurrently offering, please use that. That will already make things easier for you. So it will, for example, create index concurrently, or in the example that before, there was a detached partition. If they use detached partition concurrently before, they wouldn't have the same issue, because at least they wouldn't be blocking the reads. And that would already allow them, because their tool that was handling this operation didn't set concurrently, and they thought they did. And when they are detaching a partition, they didn't expect that it will actually stop reads from the main table as well that the partition was. So it's kind of unexpected, but when you use concurrently, there is like Postgres divides them to two inside transactions inside. So it takes basically the lowest level of locking, and then at the end it has to still do the exclusive, but it's much easier on the system, so it will allow other operations to proceed. But nothing is of course free. Like I use concurrently, I'm done now, like all my problems solved. It's not like the case. They will take longer to complete for sure, and they are not transactional, they are non-transactional, so you can't put them in the transaction block, and they can't be rolled back. So something to be aware of. And they will require additional care, because sometimes there will be failures, they can leave the partial changes. But there are commands, let's say in case of this detaching example, there are like commands like finalize that can clean up or finish the work. So there are options, but yeah, it's not like I did this, I'm done, but treat them with care. Again, the other things. The other, I think, most effective strategy when it comes to the reducing log contention, you have to break down the large DDL operations into like kind of smaller and less blocking steps. This is what we do behind the scenes in the PG role, which we'll show as well. But this is what you can do with any tool that you use, or just raw SQL. So the command that I use here, the first command, it is requiring an access exclusive log. And that means that it will actually rewrite the entire table. And if your table is really large, this means that it can actually cause significant downtime. And because you block everything, even the selects. There's also like you hold all this, you hold the log for the entire duration of the table rewrite. You ideally want to avoid this happening to you at all. So what we do here is that I actually divide this to 3 statements. First, I'm adding a nullable column with a default. So I do this alter table at column and default. And then I populate any null values in the second update command. And you should actually do this in batches. You shouldn't do this all at once, because you don't want to have this long-running query too long. And then at the last step, I am coming and I'm adding the not null constraint. So there are like several advantages. Why? Because the initial column addition, the first statement, is really quick, and it requires only a brief access exclusive block. And the second, the data module population part with the update that I'm running, now it doesn't need to have the access exclusive, because I separated it. I'm running an update, and that only takes row exclusive block, which means that the other concurrent operations can happen. And then in the last step, I just add the not null column. And that means that I'm actually trying less restrictive log, I'm taking it, and I'm holding the logs for shorter duration because I divided them. And of course, when you are like doing this type of operations, it's better to actually observe your system, what's happening. And maybe sometimes you might need to explicitly log things to prevent unexpected concurrent access happening to you while you are doing the schema changes, for example. OK, and let's continue more for the same example. Is there anything that we can do better? Here is another, I think, well-known practice. We will do, in the last step in the previous example, we have this not null edit here. So I thought maybe we can do this better. So what we can do, it is still an improvement, right, comparing to what it was before, but we could still improve it, because it is still taking a long time. It is blocking writes. It is improvement, but it's not the best. So how can we further optimize this? This is something that we can use here, check constraints. We can leverage them. Why? Because we first add the not valid check constraint. And that is like, the reason that I do this, not valid means you have the check, but you are only validating for the new data, so you don't care the existing data. That's already an improvement. And then you are validating the constraint, and the scan during the validate doesn't block writes. You're already, again, get another improvement. And then after this, you can actually add the set not null. And now it is really for Postgres. Now if you want to set not null, basically, it's only a metadata operation for Postgres. Basically, it's smart that now there's a valid check constraint there, and it will still take an access exclusive log, but it will be brief log. And then you just drop the other check constraint, and then you can just continue as the way that you just drop the constraint and you have the set not null if you want to. I think this is really smart and a good way of handling it to make sure that you're aware of this concept as well. And that brings us to the takeaway 5. As I said, splitting actions clearly takes an expertise, so you need to know what you are doing, but it is often necessary because this way you can actually minimize the locking. So try to find an approach that requires less locking. And sometimes, of course, some things are really impossible and you can't really do it just like plain SQL. And that's why I think in the tool, it was one of the motivations we wanted to implement these things so we can have high-level operations, so you can set more stuff. Like, I don't know, you can define backfills and something, which Andrew will mention later on. And I think the most important takeaway in every Postgres talk you probably attend, Postgres keeps getting better. And it has many optimizations for DDL, and it continues to improve with each release. So for example, let's look at this example that I created here. This comment, the not null default one comment that I share here, it still requires an access exclusive log, and it still blocks the other operations. But if you are using a modern Postgres version, it is really quick, because Postgres recognizes that this is a constant value. It is it's not a volatile value. And then it can be stored as a metadata, so it doesn't need to rewrite the table. So if you are using an older version of Postgres, you don't get this optimization. But if you are using a new version, this is very simple. It is very much less disruptive in the production. And if you were running this the same thing in an older version, you would still have a full table rewrite for this operation, like the one that we had before in the other comments that it was our beginning of example. You would have to have the same issues. That's why upgrade if you can, and hopefully you could, and benefit from all these optimizations that comes with the different reduced log modes. You can have more concurrently, that is for the DDL operations, and the log mechanisms themselves are basically improved. Yeah. And now I will give the talk to my colleague Andrew, and he will explain PG role for the rest of the talk.
Hello, everyone. My name is Andrew Farries. I'm a staff software engineer at Zeta. I'm going to talk about some practical examples of some of the issues that Gulçin has talked about in the first part of her talk. So to do this, we're going to introduce pgrole, which is an open source schema change tool that we built at Zeta. pgrole aims to do zero downtime, lock-safe, reversible schema changes for Postgres application developers. We're going to talk first of all about some of the design goals behind the tool, and then we'll do a short demo of how it works to show some of its features. So firstly, the design goals that we had in mind when we built this. The first thing we wanted to do was to build a multi-schema capable schema change tool. So by this, I mean that every time you make a schema change through pgrole, you end up with two resulting versions of your database schema, one version before the change and one version after the change. So for example, if you are adding a check constraint to a column, With pgrole, you will end up with a version of your database schema that has the constraint applied and one version that does not. And pgrole does the heavy lifting behind the scenes to ensure that the data in each view of the database is kept in sync. By presenting multiple versions of a schema, applications can then choose which version of the schema they want to work with. And this makes rolling out versions of your application, different versions of your application, much simpler. It becomes much easier to synchronize database schema changes with application changes. You can just roll out 2 versions of your application and have them coexist side by side, and they can talk to the version of the database schema that they expect. The second thing we wanted to achieve was to build a tool that has no nasty surprises around locking behavior. So Gulcin has mentioned a lot of the traps and pitfalls that you can fall into when you're doing schema changes in Postgres. And there are lots of sort of well-known workarounds for these things, like breaking down operations that would require access exclusive locks into multiple steps to avoid the long-lived lock. And these techniques are well known to people experienced with Postgres, but they are often much less well known to application developers who are focused more on application code. So we wanted to build these kind of smart locking behaviors, this Postgres operator-specific knowledge, if you like, into the tool itself so that more people can benefit from this kind of knowledge and avoid these kind of pitfalls that can often lead to application downtimes. So to help show pgrole, we put together a very simple example application. It's a straightforward 2-tier web application with a front-end UI connected to an API server talking to a Postgres data store. What we're going to do is roll out a second version of this application, and we'll see how pgrole makes that application roll out much more straightforward than it would otherwise be. Version 2 of the application, even though version 2 of the application makes incompatible changes to the database schema. The application itself is really boring. It's just a to-do list application. We can add items to it one by one. And at the database layer, it's also similarly straightforward. So we have the items table, storing every item in the list. And the database schema is also straightforward. So we have those 4 columns: ID, name, done, assignee, and a primary key on the ID field. What we'd like to do now is change the application so that there are only 2 valid assignees for items in the list. We can only assign either Alice or Bob as assignees. No other assignees are valid. From a database perspective, this is obviously a really easy change to make. What we want to do is add a check constraint to the assignee field. But this is already quite a difficult change to make from an application point of view, and it's difficult for a couple of reasons. The first one has to do with the locking issues that Gulcin has been talking about. If we add a check constraint directly to a column naively, then we will take a long-lived access exclusive lock and potentially lock out reads from the table for the duration, however long it takes to check the constraint against existing rows. The second reason is difficult, has to do with application rollouts. So we've seen we have version 1 instances of our application in production, and if we apply this schema change, add the check constraint directly, we will break those instances that are currently running in production. Version 1 instances allow free-form entry of assignees, and those inserts will then fail at the database layer, and users will see errors in the v1 versions of the application. So what we'd like to do is find a way to apply this schema change in such a way that, firstly, it's lock safe, so it doesn't risk locking the table for a long time. And secondly, we'd like to roll this out in such a way that we can keep version 1 instances running alongside version 2 instances at the same time. We can take a look at the migration that's going to help us do this. So the first thing we notice is that we write pgrole migrations declaratively. Here we've chosen a JSON format to express the migration. By expressing migrations declaratively at a higher level than just SQL statements, we allow ourselves to delegate the responsibility for the individual steps to achieve the migration to the tool itself. In particular, this means that the tool can run the correct sequence of operations to avoid taking long-lived access exclusive locks on the tables that it's modifying. The migration itself is fairly straightforward. We're going to modify the assignee column on the items table. We're going to add this check constraint. And then we also have these two up and down data migrations defined as well. And we'll talk in a moment about what they do. First, though, we're going to start the migration. So migrations in pgrole are split into two phases. You first start the operation, and then at some point later, when your application rollout is complete, you complete the migration. So we can start the migration and roll out the second version of the application. This is really similar to the first version, except it enforces this extra constraint on the assignee. Notice that when we added data through the first version of the application, we added an assignee that doesn't meet the new constraint. This item is still present in the list in the V2 versions of the app, but it has a slightly different view of the same entry. So behind the scenes, we've been able to create a kind of virtual schema that allows V1 and V2 to coexist at the same time during the application rollout. We can add new entries in through the second version of the application. And because they're connected to the same data store, behind the scenes, pgrole is ensuring that the data between the two schema versions is kept in sync. More interestingly, we can add items through the V1 versions of the application. Had we applied the migration in the naive way, we would have broken V1 at this point, but we're able to support V1 and V2 simultaneously, again, just having slightly different views of the same underlying data. If we go back to the schema, we can have a look at what actually happened when we started the migration. So if we look at the items table again, the first thing we notice is we have a new field in the table. So we've kind of duplicated the assignee column, and we've backfilled it with data. So the data is almost identical, but any rows that did not meet the new constraint were rewritten. And they were rewritten using that up data migration from the user, that up data SQL expression from the user's migration file. In terms of the schema, we see we have the new duplicated assignee field. And we've also applied a constraint. And the constraint has been applied to that new field. So we haven't modified the original assignee field. We've duplicated it and added the constraint to the new one. Notice also the constraint was added with the not valid modifier. This is for the reason that Gulchin mentioned in the first part of the talk. We split the operation up into two steps so that when you start the migration, it's not checked against existing rows. When you complete the migration, then it is checked, and this avoids a long access exclusive lock. We also have these two triggers defined. We call them up and down triggers, and we'll return to those in a moment to explain what they do. The other thing that happened to the database schema when we started the migration was that we created these two new schema in the database. We call these version schema, and each version schema contains a view on the underlying items table. The first version schema is just a straightforward one-to-one projection of the columns in the underlying table. And this is intended to be consumed by the V1 versions of the application. In the second version schema, we have the same view, but this time the assignee field is a projection of the new assignee field from the underlying table. And this is how we're able to present two different versions of the table schema to two different versions of the application. The V2 versions of the app will set via the Postgres search path that they want to consume this version of the schema, and the V1 versions will consume the old version schema. If we return to the table schema again, we had those two triggers that we didn't explain the first time around. So the first of these triggers, we call it the up data migration trigger. This was used when we backfilled the column, the new assignee field. We copied values over from the old one and rewrote them using this trigger. But that's also an ongoing process. So as data is written by old V1 instances of the application into the existing assignee field, it gets rewritten and copied into the new assignee field using this trigger. And they're copied using the up SQL expression from the user's migration. So this is how we're able to keep the data in the two versions of the items table in sync as different versions of the application are writing to the table. The down trigger just does the same thing in the other direction. So as we write data in to the table from the V2, the new versions of the app, the trigger and the user supplied down SQL ensures that it's present and visible to the old versions as well. At some point, we will have completed the rollout of our V2 versions of the application and we'll have no more V1 instances left in production. At this point, we can complete the migration. So this is the second final step of running a schema change with pgrole. And this has the effect of cleaning up the database schema and putting it in the final states that you'd probably expect to see had you applied this migration directly. So we've got rid of that temporary new assignee field. In fact, we have deleted the old one and renamed the new one. And now the check constraint is applied to that field directly, as you would probably expect. And we have also validated it using that two-step approach that Gulchin mentioned earlier. Completing the migration also removes the first version schema as well. So we are no longer able to support V1 instances of the application. Only V2 versions can access their version schema now. So at this point, we've successfully rolled out the V2 versions of the application. And we were able to do so side by side with the existing V1 versions by presenting two different virtual schema to the two different applications. And we did this in a way that was lock safe and allowed the two versions to coexist side by side. One thing that we didn't touch on in the demo was something that Gulchin mentioned earlier, which is how we can safely apply schema changes without risking long access exclusive locks. How we can apply schema changes without blocking other DML operations on the same table. So if we have a long-running select statement that takes an access share lock, and then if our timing is unfortunate and we try to apply an alter table statement that requires an access exclusive lock, the access exclusive lock gets queued up behind the select statement, and then any further select statements that require access share locks get queued behind that DDL operation. And this results in an outage from an application's point of view as it's unable to read the data in the items table. So as Gulchin mentioned earlier, the solution for this problem and the one that's implemented in pgrole is to always ensure that when you make a DDL change, such as an alter table statement, that you do so from a connection that has the lock timeout set to some small value. 100 milliseconds or so is typical. This ensures that if the lock acquisition fails, we try to acquire the lock for a very short period of time. If it fails, then the DDL statement gets out of the lock queue and unblocks any select statements that might be queued behind it, preventing an outage. We mentioned earlier that applications should select which version of the database schema they want to work with, and this is achieved by using the Postgres search path functionality. So an application that wants to consume the most recent, here the second version of the database schema, should do so by setting the search path to that version schema that we saw during the demo. While the search path is set to that value, we can't insert values that violate the constraint. We set the search path back to the old version of the schema, and now we are able to insert arbitrary values in here. So this is how applications can choose their schema version. Okay, so the final takeaway then is that these techniques are things that you can do yourself manually. The particular technique that pgrole uses here is called the expand contract pattern, to first expand your database to accommodate two concurrent applications side by side, and then contract it again. These are things you can do by hand. You can also apply the same sort of techniques that Gulchin has mentioned for avoiding exclusive locks. But smart tools, schema change tools like pgrole can help you avoid some of these pitfalls. So I think we're almost done for today. We're happy to take any questions either now or later. We're at the Zeta booth in Exhibit Hall A. pgrole is open source, so you can look at the project on GitHub. And we also have pgrole.com, where we have the documentation and also blogs about similar issues to the ones that we've discussed today. Thank you very much.
Yeah, thank you both for a great presentation. So, of course, we do have time for questions. Any questions out here? Okay, give me just a sec. There with the microphone.
How am I going to do this with the mic? Can I have to answer all the questions? It's not what I signed up for.
Forgive me for this question. I'm not quite familiar with update not null. What's happening under the hood there?
With which part specifically?
I'm sorry, set not null?
Set not null.
Yeah. And you had, when you were doing the alter tables, you're doing set not null. So I get that it's a non-null value, but what's actually happening? Is it some random number? Like what is actually being assigned to, or how is that? Gotcha. It's not, you're not setting the value. Okay,
Yeah,
that's
yes,
what I was
you're-
like, what is the value? Thank you so much for that.
Yeah, that's right.
Question?
The other speaker didn't bear with, probably should.
How many of these concepts would apply to databases other than Postgres, or are they Postgres specific?
It's not Postgres. Maybe you repeat the question.
So the question was how many of these issues that we've discussed today apply in other database systems besides Postgres?
Yeah, for example, could pgrole be ported, or some parts of it, could it be ported to another DBMS?
Yeah, so I guess there are two parts to pgrole. The first one is the multi-version capability, and that part could certainly be implemented in different database systems. As for the locking part, that's much more Postgres specific, so that part would look very different for different IDBSs. To be honest, I'm not entirely sure how the locking picture looks for other databases like MySQL.
Like similar looking behaviors as well. It's hard to, you all have to respond everything.
Yeah.
Can I just comment that on the topic of your question, that very few other databases have transactional DDL, if any.
Yeah. So they probably don't even have the capacity to do it.
All right, thank you for the presentation. I'm super happy when people talk about these things because normally people do not talk about them. And classifying the logs is, as much as I'm dealing with it, I'm always like going back to the documentation, did I get it right? Because it's so convoluted, so not obvious. So I think like this presentation actually very good reference tool for like people who are doing it on a regular basis. So one thing, it's not a critique, it's suggestion, because again, one thing I recently ran into, and I'm happy to share it. Did you try to test pgrole against simultaneous DDL? Because the problem, what Jimmy just mentioned, so in Postgres, DDL is transactional, but not MVCC. And doing it with applications, I ran into like very interesting things. So I do not know whether you tested it against it, and if not, like that's something like actually you probably should.
I can respond. Or you may repeat the question maybe? Should we repeat the question?
You can take the mic and respond, I think.
We couldn't figure out the logistics of it. So maybe I can repeat the question. So thank you, Hetty, for the comment. So you're asking if we tested, the question was if we tested pgrole with simultaneous DDL. Against
DDL. So basically, one transaction does DDL on the same table as the other, because that's like very interesting.
Yeah, we are actually building a benchmarking framework for PG role. So we are actually collecting use cases that people are interested in. We start currently, I'm part of that project, and we are like doing these things that is expected, like only one DDL running, and then how the impact of the PG role in the system. But I will add it to the case because I don't know the answer, how it will be, like, well, how it will behave. And yeah. But it's a good thing I noted it down. Yes, of course. Yeah. Any other question? I can bring or we can bring the mic. Okay. Good. Okay, then thank you.
Thank you.
Check 1 2. Check 1 2.
That one I did have to switch the batteries on.
Oh, you did? You just switched them? Yeah. Oh, perfect. Okay, cool. Check 1 2.
Hey everyone, thank you for showing up on time. We are going to give it another couple of minutes. I know a lot of us had gone to lunch, so I think we still have people coming back and should be with you shortly. Thank you.
Testing.
Okay. Hey, everybody. Thank you very much. Thanks for coming back. Friendly reminder, you are in the Postgres at Scale room. I hope that's where you intended to be. Our next talk is going to be 9.2 to 15 and beyond, presented by Nick Meyer. Nick is a staff software engineer with academia.edu. His talk today will cover the challenges and complications he faced when upgrading their main database from 9.2 to 15. He'll also share some of those new features he found that have made it to his personal best list. We'll take questions at the end of the presentation. I'll walk the microphone over to you since we are recording. We do ask that you not just yell them out. Make sure we get you mic'd up. And with that said, let's welcome Nick. Thank you, Nick.
Thank you. All right, just to confirm, people can hear me. I think sounds like you should be able to hear me. Thank you, SCaLE, for having me, and thank you all for being here today on this fine Friday afternoon. I'm certainly delighted to be here today to share this story about how I upgraded at academia.edu, our main Postgres database, from version 9.2 to 15. And in case anybody is wondering, the and beyond in the title is, let's say, aspirational. But before we get into all of that, let's start at the beginning. Before my involvement in the year 2008, when a startup was born and a database is born. All right, so in tech is, an industry that, at least compared to geologic time, things tend to move quickly, and in my opinion, sometimes this is a good thing, but other times, how should I put this, 1 decade, 2 decades down the line, your database starts to look a little bit like an archaeological site. We may have certain questions about why certain things are the way they are. What is this table for? Who came up with that schema? What is this custom type? Why is there a schema whose name is my manager's name just sitting around? And the written record, be it Slack, Git, old email threads, might be a little bit sparse or insufficient as far as it pertains to answering those questions. But that being said, just like good, the archaeologists that we are, we can draw some inferences. This particular database, I have some strong circumstantial evidence to believe, at least, that it was at some point, perhaps at initialization on version 8.3 or maybe earlier. At some point, somebody upgraded it to 9.2, and that's the point where I came in, around 2018, when I joined academia. Speaking of which, I think an introduction might be in order. Hello, my name is Nick Meyer. I'm a staff software engineer at academia.edu. We're a small startup. We're predominantly, you can think of us as a social network for academics. Our mission is to accelerate the world's research. My GitHub handle there is Aristocrates, like Aristotle and Socrates mashed together. I'm currently the team lead of our platform engineering team here at academia. You may ask, what does that mean? Think of us as the bridge between, the developers and the application layer and the infrastructure. That means we have a bit of an eclectic set of things we might do. Sometimes we work with Ruby on Rails, sometimes Ansible and Terraform, and sometimes we upgrade Postgres. By the way, that QR code and link, if anyone is curious and following along, that repo just has, a README and a version of the slides. It's also, I think I updated it this morning on the SCaLE talk page as well. I'll leave that open a couple more seconds for anyone who wants to scan it. If not, what is the point of this talk? I know, very confidence-inspiring thing to hear from the speaker right now. But 9.2 to 15, I don't know how many people are, am I the last one who's ever going to do that? Is there anyone else who still needs to do that? Or, maybe there's plenty of people who want to, but is there anybody who can at this point? Is the point of this talk to learn how to use old, out-of-date tools that you probably shouldn't use anymore if you have any other choice? I'm going to say no, but really my principal goal of telling this story is I think that telling stories like this is something that helps us broaden our perspectives, broaden our empathy for one another. And as far as technical details are concerned, I do plan to go quite a bit in depth into at least certain technical details that I find either particularly interesting or particularly frustrating. But as far as you're concerned, feel free to either ignore them or pay attention depending on your preference. Really, Really? Oh, next door? Okay, cool. I thought I was doing something wrong. Anyways, my primary goal here is for everyone to kind of take a step back and consider who you are. What are each of our roles in the community? Are you a contributor? Are you a new community member? Are you doing a similar upgrade from, let's say 9.2 to 15? If so, congratulations, welcome to the club. Really what I want you to know is if you're struggling with something with Postgres, you are not alone, and the primary thing that I'd really like for everyone to get out of this is to consider for a moment, how do we do a better job understanding one another's perspectives when we're struggling? And, maybe one potentially illustrative example of this is, there's a certain phenomenon that sometimes occur. I'm going to be a little tongue-in-cheek on this slide. You ask for help, you're running into some difficulty with an old version of Postgres. The fact, suppose you're actually on a very old version of Postgres, as it turns out. I certainly was when doing this upgrade. the fact that you're on a really old version eventually has a way of leaking out in the conversation, and often the response from someone who's trying to be helpful is, oh dear, PostgreSX, that's been end of life for Y years. And it's not necessarily the most actionable thing to hear if you just mentioned like, hey, I'm working on upgrading it and I'm running into a problem that's blocking me. I think it's important to think of it from the other perspective as well, though, in this scenario. I'm sure it's frustrating if you're someone who really likes to jump in and help on mailing lists or the community Slack or what have you, just to hear users complaining about the same problems day in and day out, and if only they just upgrade. This was fixed years ago. So anyways, enough about the goals of this talk. Let's talk about this database. Well, there's this certain process that has occurred several times at academia throughout history, which is we run into some sort of scaling problem where Postgres is the constraint, especially around writes, and we determine Postgres is the bottleneck. Okay, we need to find some way to lighten the load of Postgres. All right, what are we to do? Okay, here are a bunch of tables. They could theoretically, they make sense it would make sense if they lived together somewhere else. Let's move them out of the database. And sooner or later, our data layer as far as Postgres is concerned, starts to look a little bit like a phylogenetic tree, organically evolved over time. Vertical sharding, so to speak, as opposed to horizontal, where you're actually more deliberately splitting tables across different clusters for scaling. But today, the focus of this talk is going to be what I call, or what we call main. Main is the common ancestor of everything. Main is the last database that we upgraded. Main was the database that was still on 9.2 until recently. What is main? What are its characteristics? Main has all the tables that were left over after we had, gone through this iterative process of vertically sharding our application, but organically and chaotically, reactively, so to speak. It's also, coincidentally, the place where developers most enjoy adding new tables because it has a lot of nice, convenient stuff that you want to join against. In terms of scale, there's about 600 tables, give or take, 5 terabytes. Maybe some people in this room are thinking 5 terabytes. Wow, that's a lot of data. Maybe some other people in this room are thinking 5 terabytes. That's cute. Regardless, I will say that, in my personal opinion, it presents doing an upgrade, even at this scale, presents some interesting challenges. There's also a little bit of creativity in terms of procedural functions, custom types, constraints, nothing too out there in terms of extensions. So let's jump into how this talk is going to be organized. So we did this upgrade in 2 steps. The reason why we did it in 2 steps is technical, and I'll get into the details of why later. But we went from 9.2 to 9.6 first, and then after that, we went from 9.6 to 15. First stage using PG upgrade, second stage using PG logical. Now, for the purpose of this talk, I'm going to pretend that this was some smooth process, like, let's say a flight with a layover, no delays, nice and clean as far as the story is concerned. In reality, it was really a lot more like a winding road trip with a lot of diversions for different, chaotic priorities that came up and superseded everything else. Log4j, if anyone remembers that, several years back, or fixing our backup system, Python packaging issues, Java packaging issues. Did I mention, by the way, we're a Ruby on Rails shop, and yet somehow the Python and Java packaging ecosystems become my problem? Anyways, enough of that. Let's move on to part 1, 9.2 to 9.6. How did we do it? Well, maybe first, why exactly did we do this? I alluded to this earlier. We stopped at 9.6. There's a technical reason. In order to get into that, it's important to cover a little bit of background on the underlying storage format of date times. Prior to version 8.4 of Postgres, and I've linked to the release notes and also relevant, at least what I think is the relevant commit message. Prior to version 8.4, the default for this was a floating point representation, but from 8.4 onwards, this was switched to a 64-bit integer version. Remember, I said that this database must have been initialized on 8.3 or earlier, back in 2008. So if you wanted the old behavior, it's of course it was of course possible to revert to that at compile time when you compile the Postgres binary by passing -- disable integer date times. And one sort of like broader theme that I want to get across here is that with data, when data is concerned, in databases especially, the decisions you make, or in some cases the decisions you are forced to make, will echo for years onward, at least sometimes. And in this case, if you have a cluster where the Postgres binary was compiled with this disabled integer date times flag, at least if you want to use PG upgrade, you have no choice but to continue using it over and over again for each successive version that you want to upgrade to, because PG upgrade is going to complain if you try and mix and match or migrate off of it using PG upgrade, because PG upgrade just generally, or I guess it was PG migrator before version 9. Don't ask me for the details there. PG upgrade is going to complain because PG upgrade, it's supposed to be fast. It's not supposed to transform data to that extent. This actually was mostly fine for us, at least through 9.2. And in the story, it's going to continue to be fine for us for several versions higher, but there is a problem. Version 10 of Postgres removes this compile time flag in favor of just forcing you, if you haven't migrated by now, you need to use the integer format now. But we can still get to version 9.6, so let's do that right now and deal with that, pesky Postgres 10 plus problem later. All right, so general format of each of these two stages is, each of these two parts of the talk. Part 1 is that first hop, part 2 will be that second hop. I'm going to give some diagrams of like a high-level overview of how the upgrade process works, and then I'll dive into some more details that I happen to find interesting. Feel free to ignore them if they want and just focus on kind of like my emotional state. Am I expressing anger or, excitement? But without further ado, for that high-level overview, some context that's important to know. At academia, we have tons of streaming replicas. Multi-day maintenance windows are not really in our vocabulary or, Overton window, so to speak. So we're not going to do a dump and restore and slowly bring everything up and then bring everything back up and then bring up all, the replication tree and all of that. Using PG upgrade when you have streaming replicas and you wish to do so with very little downtime can be a little bit complicated and perhaps, as we'll see, even a little bit dangerous. Furthermore, we wanted to be pretty careful with this operation. So PG upgrade is something you can do in place if you want to. We chose not to literally do it in place on our infrastructure that was, our old infrastructure. We chose to instantiate an entire new replication tree, where by that what I mean, we'll have a new streaming replica. It's still doing physical replication. It's still on version 9.2. It's designated as the future new primary. We're eventually going to run PG upgrade on that, and then cascading replication down from that is, a new set of streaming replicas that looks exactly like that tree on the left. And at any time, everything that we're going to do that could potentially be destructive, we're going to be doing on this new tree to the right. If something goes wrong, we can always roll back. Pretty safe, right? We'll see. Okay. So what is, I guess, step 2, but what's the first step after we set all of that up and everything is caught up to date? First, we're going to stop writes or block writes in the application. Thus begins our maintenance window. We then promote the new primary, so it's still on version 9.2, but it's not streaming replication anymore. Okay, and what is the next step? The next step is to draw the rest of the owl. Follow the simple 17-step guide as pointed to by the 9.6 version of the docs, but don't forget to reference the latest version of the docs. They have some important details that are maybe a little bit missing that could cause some issues like corruption. No big deal, right? Okay, let's dive into the details of, at least some of the details of that simple 17-step guide that I alluded to. All right, so we're on the new primary. We've just promoted it. It's writable now. What we're going to do now in this step 4a is we're going to install the newer version of Postgres, and we're going to run initdb to generate a new PG data. So we still have Postgres version 9.2, both the binary directory, which has the executable Postgres that actually runs the code to run the database, and then there's also the 9.2 PG data. Alongside that, in some other directory, we have the 9.6 version of those two things. But keep in mind, PG data is pretty much blank for the 9.6 version right now because we haven't done anything yet. Next, what we're going to do is we're going to stop Postgres on the new primary, but, and this is important, we're going to keep it running on the the replicas of the new replication tree for now. Still have not run PG upgrade. All right. Before we do that, before we actually run PG upgrade, we are now going to check that the latest checkpoint location as reported by PG control data, when we run that on both the new primary and all of the streaming replicas, matches. If they do not match, we do not proceed. We roll back and try again later. One, academia-specific thing that we do, since, so far everything I've mentioned is pretty much covered by the docs, at least the latest version of the docs on PG Upgrade, running PG Upgrade with streaming replicas. One thing that we did is we have this Ansible playbook that's responsible for actually doing the upgrade. We did have this Ansible playbook back when we needed to use this process to upgrade. It runs basically this loop for some amount of attempts that just checkpoints repeatedly, one after the other, on the new primary and then the new readers while they're all still running. So this is before we shut down Postgres in step 4A or 4C or whenever that was, before step 4B. And it tries to get them to the same version and then, shuts down the primary. Okay. Now we're finally going to run PG Upgrade after doing all of that. We're going to run PG Upgrade from the new, so both the 9.2 and 9.6 directories are going, binary directories are going to have PG Upgrade. You need to run it, it's advisable to run it from the newer version. I have never actually tried not doing that, so I don't even know what happens. I'm just assuming bad things can happen. And we're going to run it with --link. This is the mode that uses magic and hard links to make this operation a lot quicker than if it had to actually copy the physical data files. In either case, I believe it's not actually doing any data transformations. It's keeping the binary format the same. All right, and now we're going to stop all of the replicas in the new tree, and we're going to run some rsync command. Okay, folks, if you weren't concerned thus far, now is maybe a good time to start being a little bit concerned. There's certainly some red flags I see here. --delete, size only. I'm a little bit skeptical, but let's assume that this works fine and proceed for now. What would we do next, assuming this finishes successfully? Then we start the new primary. It's on version, it's officially on version 9.6. So, start Postgres 9.6 on the new primary. And then start the new streaming replicas. And then we're still not, we're still in our maintenance window. This is also maybe another slightly academia-specific thing, is that we run analyze, I think the docs do tell you to run analyze, I believe, analyze in stages on all tables. We actually preferred to run analyze prior to restoring any read and write traffic. Analyze in stages, the idea there is you do like a rougher estimate of the stats in the earlier stages, and once you're done with that, that's good enough. You can restore traffic to your site, and things might be a little bit slow, but at least you can get at least partially up and running a little bit faster. We have caught corruption at the stage, or things that seem to be corruption, just by running analyze. So we thought, we found it, we have this institutional knowledge, at least on our data set, that it's worth it to just wait and see if anything fishy comes up when running analyze. I wish I had more details. It was in a run of this. It was in an upgrade using PG Upgrade a little bit before my time. Like I mentioned, that phylogenetic tree, we did test this process on a lot of databases before, risking it all on main. Some of the lessons we learned through pain. So this does extend the required maintenance window, but hopefully it was worth it. And then finally, once all of that is done, you point the application at all the new nodes. Writers go to the primary, writes go to the new primary, reads go to the new readers, and great. Should you do this? No. Okay, fine, it depends. So what could go wrong? Really the main failure mode to worry about is a little bit specific to if you do the streaming replica version of this, that rsync command, has some failure modes that can be kind of bad. I put a lot of links in here for anyone who looks at the slides later to peruse at your leisure, including one pretty recent one from Adyen. This was written in, I think, January 2025, about yet another way that you might run into database corruption on your standby nodes if you do this process and something, a certain set of circumstances converges to cause problems. So, I would recommend do this maybe, if you have no other choice, then probably you want to do this anyways. Just, I would recommend proceed with caution. Make sure you read up on the things that can go wrong. Regarding I think there was some discourse on the mailing lists at some point around this. How there are certainly some people in the community who feel a little uncomfortable even recommending this in the docs. My perspective is a little nuanced, I would say. Since the reason why it remains in the docs today is that there are people who do this and say that it works. I guess myself included, technically, although personally I never want to do this again. Not super comfortable with this process. I think the real experiences that people in the community actually experience, people report hey, I did this and that rsync command looks kind of logically unsound, but it works. I think that, that's data and it matters. Anyways, let's move on to part 2, going from 9.6 to 15. So let's review our options, since as I mentioned before, we have some considerations. We don't want to take large maintenance windows. We still don't want to do that. So pgdump, pgrestore, not really an option. I estimated it probably would take about 2 days. Maybe if we tried really hard and really optimized and rehearsed this process, we could have gotten it a little bit better than that, but pretty much a non-starter. PG upgrade. As I mentioned before, our good friend disable integer date times is a blocker there. And no, we're not going to patch Postgres 10 or find someone who can help us with that. No, Postgres 10 removed support for that compile time flag. It would be great if we finally just found some low downtime way to migrate off of it. And that brings us to logical replication. Logical replication, at least in theory, is an option that lets us do, it's an option that lets us have no downtime, or almost no downtime, much less downtime than the previous process, certainly much less downtime than pgdump and pgrestore. The super high level gist, which I'll give a slightly lower level, high level gist of how it works, is you instantiate what's called a logical replica. This replica it'll just be on the newer version of Postgres. It'll have a logically equivalent copy of all the data. It'll be keeping in sync in real time using logical decoding. And then you just cut over when you're ready. Sounds great, right? Well, we'll see what might go wrong there. So one potential problem here is, as we might be familiar, built-in logical replication was not actually added into Postgres core until version 10. But there's an extension called pglogical, which works with version 9.6. We're on 9.6 now, so we can use pglogical. It also works on versions 9.4 and 9.5, but we're on 9.6, even better, right? All right, so really funny story about this. In terms of this recommended reading, so Sean Thomas, who I think is actually here, and also gave a talk earlier today, told everyone in the audience not to read his book. I might add a little bit of nuance here where if you're specifically using pglogical, I will say that I personally found the chapters on logical replication as they pertain to pglogical and the zero downtime upgrades pretty helpful in just, giving good worked examples of how to actually do this. Even though Postgres 12 is no longer supported, I don't think pglogical has changed all that much since in the past several years. Okay, so what is the high level overview of how you do a logical upgrade? Well, on the left here, we have our primary, our existing database. It's up, it's serving client traffic. It has a bunch of read replicas and so on. What we're going to do is, with this green new primary, we're going to install Postgres 15 on it, initdb. We don't need to worry about disable integer date times. All we're going to do is give it the same schema as our old cluster. And I'm not going to I don't intend this to be a fully comprehensive guide on exactly how you do this. There's some guides on the internet that tell you which pgdump all commands or pgdump commands you can run to get the schema and load it there. And there's even some nuances around how much of that you want to do before loading data or after loading data. But let's, for simplicity, assume that we have the same schema. It's just, same table definitions and everything. It's just totally blank as far as actual data is concerned. Then step 2, which I will really just brush over and pretend is just this one simple step, is you copy over the data and you logically copy over each table and then stay in sync with changes. pglogical pretty much handles this through its syntax. In reality, if you're database is about 5 terabytes large, it takes a little bit of time, and there's a little bit of monitoring you probably want to do here. But let's say you do that, and changes are streaming logically in real time. You have this Postgres node on Postgres 15 that's staying in sync. Now what you do is bring up a replication tree that looks identical to the one on the left. So we're pretty much in the same situation here as I described before with that 9.2 to 9.6 upgrade. The only difference is we don't need to do anything potentially destructive on our new tree, like run PG upgrade. It's just ready to go as soon as we point traffic to it. So are we going to do that right now? I mean, I guess you could, depending on your risk tolerance. One thing that I personally really like to do, in my opinion, this catches like 90% of just random problems that might come up, especially around like query performance. Like some query, it's working fine, but it's just taking a really long time. Hint, you should probably, don't forget to run analyze and, make sure your stats are good on this new cluster, especially after you load a bunch of data, is we're going to test reads. So we're a Ruby on Rails shop. We do the Ruby on Rails specific things, but if you're in a different application, do whatever you need to do in your application to point read traffic that was previously going to the read-only replicas in the old cluster. You can just point that at the new cluster. Does this work? Yeah, I mean, mostly works. The one caveat maybe to keep in mind is you do have probably slightly more replication delay than your application is used to, if that matters for you, since you have not only like streaming replication involved, you don't just have the latency involved with streaming replication, you also have this logical hop on top of streaming replication on the other end. But in my opinion, it's worth doing this. And then finally after that, you switch writes. And in particular, there is a really cool thing you can do with pgBouncer to make this an atomic operation. And this is, I'm going to call this like blue-green. Ideally, you'd have like blue-green-blue so we could roll back. But I'll get a little more into that a bit later. So the magic of how you can do this with pgBouncer is we have, pgBouncer, you could theoretically install it locally on each host. You can install it on a different machine. pgBouncer doesn't care all that much if you tell it that its upstream database that it's connecting to is localhost or 127.0.0.1 or some other host. So something you can do to make this atomic switchover in a way that doesn't even necessarily cause any client queries to return errors is there's this pause command, and what pause does with pgBouncer is that command, in the pgBouncer session, if you connect directly to pgBouncer, you can do it with pSQL and run at least some commands. You can't run tons of SQL commands there. You run pause, that's going to block for you until every query that had been executing, actually going through to a real server connection terminates one way or another. And then once it returns, every single query that started after you ran that pause command is currently just like queuing in pgBouncer and hasn't made it through, has not been assigned to a server connection. So you're guaranteed that at least, as long as no clients are trying to connect directly to the database, which that's, a whole other story I'm going to ignore. As long as that's the case, you know that no one is actively doing any write that you need to worry about. What you can then do is change the config out from under pgBouncer, do like a service reload, and then run the resume command, which will take all of those queued queries that have been just waiting to actually do anything since you ran the pause command, and then let them go through. And now, little does Rails know, it thinks it's connected to the old cluster. It's actually connected to the new cluster right now. And that bit I mentioned about blue, green, blue, you can imagine a version of this where we actually flip the logical replication the other way and make it so that, the application is connected to the new cluster, but we can roll back even at this stage if we really want to. I didn't actually do that for this upgrade because testing PG, I was just a little bit worried about all the things that might go wrong right in the last moment, trying to do this 9.6 or 15 to 9.6 reverse direction logical replication. Anyways, so one advantage of this is that this switches writes atomically. You don't need to worry about applications. run tons of streaming replicas. We also run tons of application servers. It's very hard to get all the application servers to change their mind about which database hostname to connect to all at the same time without some sort of weirdness going on. So once we've actually switched rights, we can just update the config to eventually make it so that the Rails servers just connect directly to the new writer once we're pretty sure we're not going to try and roll back at this point. Okay. Diving into some of the details here, I'm going to call that the high-level overview. Here's a list of problems that I won't go too far in depth. These are things you probably should worry about if you're trying to do a logical upgrade with pgLogical or built-in. Certainly dealing with breaking changes, maybe this is more of an issue if you're hopping a lot of versions at once. I definitely spent a lot of time before even that first step of loading the data, just fixing the pgdump, schema-only output to even load up without some sort of error popping up or some sort of problem arriving. A lot of surgical fixes were needed. In addition, there's some things you probably want to do for just efficiency's sake regarding like the order in which you create indexes and constraints. One thing I do want to mention a little bit more in depth is this note here about long-running initial syncs. So, a little bit of the details of how on a table-by-table basis pgLogical works is first you copy, effectively stage one is you copy the entire table in a transaction and you have a snapshot. From that point onward, the publisher, the logical publisher, the old database that you're trying to upgrade, that server needs to retain write-ahead log. And then when that long-running sync finally finishes, it's just doing, pgLogical, I think, just as a copy to standard out. The the logical subscriber does a copy from standard in, and you just pipe those two together more or less. Or I haven't read through the code, but that's what it seems to be doing when I look at pgstat activity during this process. Once that process actually finishes and that now stale snapshot potentially of the data is loaded on the logical subscriber, then what the logical publisher is going to do is it's actually going to start logically decoding the wall. That comes after you do like this initial snapshot. And really, that generally, sounds pretty good to me. The main downside is if you run out of disk space because you're retaining too many wall files, a lot of bad things might happen. So we want to monitor for that. A quick way that I'll mention where I slightly tune this query, I'd probably add some more columns here just to be like a sanity check that I'm looking at the right copy query. But for the sake of making the text size a little bit less bad for the presentation, really what you need is there's this great view called pgstat progress copy. It is unfortunately not available in Postgres 9.6. Fortunately for us, it gives you like metadata information about an ongoing copy, whether that's a copy to, copy to standard. Remember, we're doing like two copies here. Publisher is doing copy to standard out. Subscriber is doing copy from standard in. We can't run this on 9.6, but fortunately we're replicating to 15. So we can run it on the logical subscriber. In particular, there's this tuples processed column that we're going to use as our numerator. Now going back to the old cluster, if we just get the row estimate from, I think like PG class, we'll use that as the denominator. And that gives us a approximate percentage done. And there's other queries we can do to see how long has this query been running. So you give a straight line estimate of like how much longer is it going to take, and then combine that with some graphs of, how much wall is being written at any given time. You can get it. You should be able to like hack together, even if you don't cleanly automate all of this stuff, a pretty good, rough and ready progress bar that you can at least use to reassure yourself that you're not going to run into failure modes. Okay, so to give a highlight of some of the other complications that came up during this, let's start with schema changes, aka Rails migrations. As I mentioned, our developers love adding migrations on that main database. It has all the great stuff to join against, like the users table. Roughly like 3 to 5 schema changes per week. Infamously, as we may be familiar, logical replication does not have schema change support. Physical replication does. Logical replication, isn't currently supported. But fortunately, there's an extension called PGL DDL deploy. It promises transparent, logical DDL replication. So, are we done here? Is it magic? Perfect? Problem solved? Kind of. So, there's some caveats to be aware of when using this. You know, maybe the most engineering time I'd say was spent just dealing with the lack of create index support, and I believe this is by design, although it's a little bit buried in the README in the docs. So, you know, a lot of times when engineers write Rails migrations, they love running create index concurrently, or, you know, sometimes create index non-concurrently when that makes more sense. So we had to manually deal with this. It wasn't too bad. We just manually detected new indexes that we need to create, and we just created them on 15 before actually cutting over to that. One thing that I will point out that helped a lot with this work was the pgQuery Ruby gem. You'd be surprised how difficult it is, if you haven't done it before, to just parse out the output of pgdump and separate all the statements. You split on semicolons, and you're like, oh wait, there's semicolons in the comments. Okay, fine, I can work around that. And then, there are like definitely a lot of other corner cases that makes this more difficult than it sounds. In addition, really the main challenge here is that we just didn't totally trust it not to break for some reason. So we did institute a bit of a cumbersome QA and sign-off process just so we could take a look and make sure that nothing bad came up in our QA cluster. But overall problem solved. Just be aware of the corner cases if you use this extension. Problem number 2. All right. Little did we all know, we're going to have a second talk about glibc in the Postgres track. So imagine, well, maybe this query isn't, I tried to simplify this query to make it a little more instructive and with font size not too small. Imagine we have a unique index on some string column in a table. But when we select all rows that match that string column, using a particular way to maybe trick the planner into not just returning one of them arbitrarily. So suppose that there's 2 rows with the same string in complete violation of the unique index on that column. That's kind of bad, I guess, in general. It means there's some sort of corruption going on this table. But in particular, this is extremely frustrating during a logical upgrade because the Postgres, the newer cluster is going to have the same schema. It's going to have the exact same constraint on that column. And when you do that initial copy, it's going to fail. It's going to complain, no, you have a duplicate. You're inserting a duplicate that violates this unique constraint. Which, part of why this is so frustrating is because, like, okay, Postgres, I agree. I know this is really bad, but can you please just let me deal with this later? I really want to get this upgrade done. I promise I will rebuild this index and deal with the row somehow. Okay, I threw out the word glibc here, but just to Christoph Bettis gave a much better talk to go into all these issues with sorting strings and collations and storing human language on disk yesterday. But, and I'll admit my evidence here is a little bit circumstantial. I do believe that the likely culprit of this particular issue as it blocked this upgrade was a past Ubuntu upgrade. I believe it was from 14.04 to 16.04. I knew the timestamp of when that happened, and I looked at the timestamp of, this row and maybe some other rows lined up pretty closely as being exclusively after said timestamp. And the issue here is for those, maybe who haven't heard as much about this glibc issue. What is glibc? glibc is like an operating system package that by default, on a lot of Linux distros, is going to be used to tell Postgres which order strings should be in, which maybe doesn't sound too impressive, but if we think about human language and mapping that to bits, 1s and 0s to be stored on disk, especially when we consider those non-ASCII Unicode characters, it's a little bit complicated. And one particular bad thing that can happen if you if you bring up a streaming replica on a different operating system version than the primary is that certain operating system libraries, such as glibc, change. And glibc, I've heard it said sometimes that 2.28 of glibc is the one version that messed everything up, and that's the one to worry about. that's true, but like really every single version of glibc has some sort of breaking change. It's just usually a little bit more subtle than that one that came with Postgres 1804 or 2004 or whichever one it was, or with Ubuntu 1804 or 2004 or whichever one it was. Usually it's a little more like 1 in a million rows will be messed up or you'll get duplicates. So the reason why this is so bad with databases is that string uniqueness is enforced by a B-tree index. That B-tree index is suddenly no longer valid if your library that's telling you how to sort strings changes its opinions like under the hood without telling you. Anyways, you know, I solved this. It was like a string either in this particular string back in this example that had a duplicate. It was either, you know, it was certainly like a non-ASCII name in like some context. I think it was like a research interest. We have, you know, a concept of like which field is a certain, you know, or certain content in. I think it was either in Arabic or it was in Persian or something. It was, I want to say it was like psychology when I used Google Translate. I just added like a 2 to the end of it, or maybe it was like the beginning because how, you know, it's a right to left language. Anyways, enough of that. Let's move on to PG logical bugs. Maybe I should say like suspected bugs here. I can't absolutely prove that there isn't something wrong that I did. I certainly haven't really looked into these enough to come up with like repro, you know, minimal repro. Certainly I can confirm that like there are some things that don't quite look right that reproduced pretty reliably on my particular data set, and I never quite figured out the common denominator between all of it. But you know, one thing to be particularly careful of is if your subscriber or, you know, if the publisher crashes, you want to be really careful about whether any data loss occurred. You know, generally things are written so that it should resume just fine and pick up where it left off. But, you know, I definitely saw some cases where the replication slot incorrectly failed to stay down or like advanced more than it should have. So I added a lot of, you know, after seeing that, I lost a bit of confidence, added a lot of monitoring just to really obsessively see like does the status down or replicating or whatnot. In addition, I made an issue for this second issue. I made a GitHub issue, not like expecting anyone to fix this since, you know, the PG logical devs, assuming they're even still active, don't owe me anything certainly. There's this one particularly weird thing where I saw issues in the subscribers log when running create index concurrently. Like as I mentioned before, we had to manually create indexes that developers ran as Rails migrations on the publisher, you know, in between when we started and finished the upgrade. I worked around this pretty easily by just not using concurrently, and that seemed to not come up. Not exactly sure what's going on there. Maybe if anyone else ever runs into that particular issue, they'll chime in on that issue. All right, enough about difficulties and challenges. Let's move on to favorite new features. I'm gonna take a quick drink of water though. All right. My general rule of thumb here is I'm going to try and focus on the more esoteric or maybe slightly less appreciated features rather than the really obvious ones that we might be thinking of. First, from 9.3 to 9.6, those things that were added in some, you know, some version in that range. Lock timeout. Has anyone here ever had to work with a Postgres database on 9.2 or earlier? All right, so there's some people here who understand my pain when I say like just how great it was to finally get to use lock timeout on our main database. You know, there'd be, every once in a while, there'd be some massive site-wide outage. Okay, what could be causing this? Oh, of course, someone added a column on that one table. A problem no longer, lock timeout, or, you know, otherwise known as a lock acquisition timeout. Particularly, you know, strongly recommended to use this when doing DDL. In addition, just like anything that gives more visibility in those pgstat prefixed views, like pgstat wall receiver, you know, obviously Postgres knows who it's replicating from, right? Because otherwise it wouldn't know where to connect to get the replication stream for, you know, streaming replication. Well, now it can finally tell me. I can't remember whether that was 9.6 or an earlier version, but it certainly appeared in between 9.3 and 9.6. pgstat progress vacuum improvements in general. Now, I do know that there were a lot of improvements made to vacuum after 9.6, but just between you and me, I pretty much stopped worrying about transaction ID wraparound after version 9.6. You know, not to say I don't monitor. I do still monitor it and worry about it a little bit, but whatever was done in between 9.3 and 9.6 to improve vacuum certainly fixed a lot of our personal pain points with it.
All right, so there's certainly some things we already probably know about between 10 and 15. Built-in logical replication, declarative partitioning, the merge statement. I'm not going to cover any of those because yes, we do, use at least some of those, and I think they're great. What is my esoteric list of features that I really love between 10 and 15? pgstat statements info. So who here is using pgstat statements? So few people. No, I'm sure, pgstat statements is great. It gives you, aggregated view of your query performance over time. pgstat statements info solves this one particular pain point that maybe some of us have had, where let's say you have 3 different consumers that all feel entitled to reset the stats, and these systems don't coordinate with each other. And so you're left wondering at all times, like, what is the time denominator of pgstat statements? When were these last reset? I have no idea because there's 3 different systems that might be resetting it. pgstat statements info has a column that at least tells you timestamp of last reset. I love it. In addition, just more pgstat progress stuff. I love that. I already mentioned pgstat progress copy. It'll even help you during the upgrade because you can see what percentage done are you syncing that one giant table. pgstat progress create index, great for the same thing but for creating indexes. pgstat progress base backup, just kidding, we switched to pgbackrest, so we now use pgbackrest info for that. But if we did still use pgbase backup as part of our backup solution, I would love that one too still. pgsequences view, max wall slot keep size, or max slot wall keep size. I'm going to call out that one in particular. We've been experimenting a lot with ETL pipelines and such, and that one has been a lifesaver since things go wrong, and I really appreciate not having to get woken up in the middle of the night by some disk alert. Anyways, what are some takeaways that are maybe a little bit broader that I was hinting at a little bit in that motivation section towards the beginning? In general, certainly for like an upgrade such as this, but also just in general when you have a project with large, long feedback cycles, it can be a little bit difficult if you run some long-running operation like load all the table, copy a snapshot of all the tables and then logically replicate after that. If you realize after all that happens, a day or a week or however long later, that something went wrong and you need to start over from scratch. So, unfortunately, the database is not sentient. Well, maybe it's fortunate that it's not sentient, but, the database doesn't really care about your deadlines. It's just storing ones and zeros. It doesn't care. That being said, I think that the approach that you take with a project involving the database can make a big difference in how many times you need to repeat your progress. In particular, I'll say never fire and forget, with a long-running operation. If you spend a bunch of time focusing on like how to monitor it, how do you build your own progress bar, how do you like confirm that it's actually doing what you think it's doing, how do you like project how long it's going to take, in my opinion that's time very well spent. You can use pgstat progress copy, or even if you're just looking at like disk usage, that can be really helpful in giving you at least some ballpark of when is this operation going to finish. Learning versus doing. There's certainly a lot of time uncertainty, like in your time estimates of when something is going to ship, if you have a lot to learn, because learning can take time. If you have a lot to learn, there might be a lot of uncertainty around unknown unknowns, what might be wrong, like what might go wrong. In particular, there are a lot of very fun things that I learned that maybe I'll call out some of them here since I didn't have time to really go over them in the rest of the presentation. Deferrable constraints in particular. I had no idea these were a thing before doing this upgrade. Apparently you can have some constraints where you're allowed to violate them mid-transaction as long as you fix things up by the end of the transaction and commit, all is good. So those are really cool. Unfortunately, pgLogical does not support these. It doesn't support replicating deferrable constraints that have done this in the mid-transaction. So I did unfortunately have to figure out how to remove these from our application and keep our application working, but I still think they're pretty cool. Celebrate with low-hanging fruit when you're done. Some examples, these are a bit like Postgres upgrade specific, but I'm sure there's like analogies of this were a broader range of projects. Add a new column with a default value. Thank you, Postgres 11. Teach someone about pgstat progress copy. People think it's really cool when they're like, oh, I started this long-running operation. I have no idea when it's going to finish. Is there any way I could just know? Well, now you can, at least as you're on a recent enough version of Postgres. And last but not least, let's seek to approach one another from a perspective of wanting to, understand our perspectives. Let's try, how do we make upgrades easier for everyone? Thanks for listening, everyone. I'd be happy to answer any questions.
Well, Jimmy, thank you very much for the presentation. Okay, so we will do questions. I'll come to you. Give me 1 second here.
First, thank you for the great presentation. My question is, the 9.6 database, like if it is running on Oracle Solaris and the 15 Postgres version is on the Red Hat Linux, so the PG logical is going to support for that, correct?
Sorry, could you repeat that?
The 9.6 Postgres version, the operating system is Oracle Solaris. Solaris operating system.
So the operating system, we happened to keep it the same in this case between the 9.6. 9.6 is the Postgres version. We were on like some version of Ubuntu. We were just on some version of Ubuntu for the 15 cluster. It was just on other than Postgres, it looked pretty similar.
So are you saying like if the operating systems are not same, is this going to work or not?
Oh yeah, sorry. That second step, 9.6 to 15, if you do a logical upgrade, it doesn't. You could change the operating system, and it should be fine. That's actually the plan when we're planning when we do an operating system upgrade, since it's getting to be about time. We're going to do a logical upgrade for that just to avoid all those nasty issues with string index corruption that can occur. That issue is mostly a problem if you do a physical upgrade, or if you attempt to do a physical upgrade, such as PG upgrade, or if you load a streaming replica, so not like a logical replica, but just using Postgres streaming replication. If the replica is on a different OS version, then the problem will also occur, at least like once you promote.
Okay. And for your 5 terabyte database, the initial setting up the logical replication on Postgres 15, how much time it took?
Oh, how much time for the initial synchronization?
Right.
Oh, for us, for 5 terabytes? We spaced it out. I'd say there probably would be ways to optimize it a little bit more if we knew exactly what we were doing and knew all the issues we'd run into beforehand and fixed it. I'd say it was like a process of several weeks for us as we stumbled into different issues. I'm trying to remember if there's like a good rule of thumb. It's definitely slower than what you'd expect from doing, if you use like most physical backup restore systems. Like physical backup restores are going to be a lot faster than doing a logical, copy of the table.
Okay. So the final question is like, after you promote the 15 database as your production database, okay, and what are the process you did for the cleaning up the logical replication? Because once the cutover is over, I don't want my 9.6 data to go into 15, right?
Yeah.
So how did you do that?
Yeah, maybe I'll go back to the step here. So one thing so more or less, I think the question was, in summary, how do you clean up like this logical replication stream, since you don't want to keep replicating,
right.
Like what if someone connects to the old one and something goes wrong? You can get rid of that here. We actually didn't in this upgrade, since I wasn't, I was a little more concerned with the rollback options if this, or to try again later if this didn't quite work in this moment. More or less, there's some commands that you run basically on the primary node and possibly also on the logical subscriber. So on both of them, there's some there's just some SQL commands you run, where with PG Logical they have their own specific syntax of how you do that. I believe it's probably all different. So it's certainly all different for built-in.
Do you have to drop all the publications and the subscribers on the both databases?
So in this example, we only have one logical subscription.
Okay.
I don't know if you're asking more specifically about an upgrade where like maybe there's multiple logical subscriptions other than the upgrade specific subscription, but I do know that like I do know that transferring over like logical subscriptions in a logical upgrade is a little bit complicated and possibly not super supported.
Okay. Okay, thank you.
Okay, any other questions? Group? Oh, yes.
Thank you for presentation. So my question about this one. So when you do, when doing an upgrade from 9.6 to 15 using PG Logical, how did you handle the sequence replication?
Oh, sequence replication. Yeah, so sequence replication is another thing that is infamously, or somewhat infamously not included with logical decoding or logical replication. It's actually interesting, if you've ever done depending on your version of Postgres, you can select from PG sequences, or you just select from the given sequence like it's a table, depending on how old of a version of Postgres is. One interesting thing you can do is during streaming replication, do that on the primary node and do that on the replicas, and you'll notice it's like a little bit funny and like eventual in the way that it even transfers over, I think, with streaming replication. But in short, to answer the question is there's a specific command you run with PG Logical at least that will sync up the sequences. It'll also like add a buffer of it'll add some like fixed offset of 1,000. So it'll like you run that command and it will make it so that like every sequence that's been added to the every sequence that you've like effectively added to the subscription using PG Logical syntax, that'll be synced over. You'll get an error, of course, if the sequence like doesn't exist or some sort of problem like that happens, and that happens like separate from the logical decoding aspect of it all. And really, you want to do that kind of in that middle step here, where I say reload. That's one of the things you do between pause and resume, in particular.
Okay. Any other questions? Jimmy, thank you very much again for coming out. Certainly appreciate it. Let's give him a round of applause, people.
Thank you.
Just checking you can hear me at the back.
Hey, everybody. We're going to get started here in just a moment. One of the things I did want to read, though, just friendly reminder to everybody, this room is sponsored. If I'm reading correctly, it is Quest Software who is sponsoring us. So I just want to give them a little plug really quick. Postgres is a great database, but managing database growth and scaling without downtime can be tricky. That's where SharePlex comes in. Real-time replication, zero downtime migrations, and easy scaling. And with Foglight, you get full visibility into performance bottlenecks. If you're looking for ways to make Postgres work smarter, not harder, talk with them after the session. Okay? And our next talk, again, welcome back. You're in the Postgres at Scale room. Our next talk is Row-Level Security Sucks. Can we make it usable? Presented by Jimmy Angelakos. Excuse me, Jimmy. Jimmy is a system and database architect and a recognized PostgreSQL expert who has worked and contributed to open source tools for over 25 years. His talk today will cover the challenges and complications he faced. Oh, I'm sorry, that's a different one. What happens when I change my schedule with the new data. Oops, there we go. Okay, yeah, sorry about that. So the talk, row-level security sucks in Postgres. Can we make it usable? Jimmy is a, yeah, I know, right? Sorry, let me get out of the way here. Jimmy worked with the Riv. He was nice enough to come by and do the presentation for us. So let's give him a round of applause for coming on out. Thank you.
Thank you. So this is the title. We'll see what it means. On to my favorite topic. Repeat some of the things you've already heard. I identify as a systems and database architect. It's something that we've kind of forgotten. We talk about software and we talk about databases and we talk about data layers, but we don't talk about systems in general. And having a bird's eye view approach to systems design is beneficial. And this is the point of these talks. It's knowledge sharing, because it's good to spread the knowledge outside the small bubble of database administrators that frequent places like this, the PostgreSQL room at SCaLE. I'm very grateful to SCaLE for the invitation. This is my second time here. I'm actually based in Edinburgh in Scotland, so I had to take a really long flight. I have been using open source and trying to contribute back for over 25 years. I have been using Postgres exclusively for more than 16 years now. Probably need to update that slide. Closer to 18, actually. And I have written a couple of books on Postgres. This is going to press very soon from Manning, PostgreSQL mistakes and how to avoid them. It's based on observations and things that I've seen people do wrong in the field, also mistakes I've made. I've also co-written with a few other brilliant PostgreSQL people the Postgres 16 administration cookbook. And I am the author of the pgStatViz extension for Postgres for visualization and time series analysis of Postgres internal statistics. Now, on to the talk. Let's see what we're going to be talking about. We're going to see what row-level security is in Postgres, when you should use it, how it works internally, how to use it, but also what's wrong with it, and what you can do about that. We will also be talking about more things you can try with row-level security. So let's look at the motivation for this talk. This is a slide I always include, is why are you giving this talk? So I had a customer at some point that wanted the users of their application to not see each other users' data. Duh. But here's the catch. This customer was used to their application being badly coded. So they expected data leaks from one user to the other. Unfortunately, the original design of their application contained things, REST URLs like /user /identifier /data. And by guessing or just brute forcing, you could find another user's valid identifier and read their data. So that's bad. So let's see what row-level security is. It gives you fine-grained control over which rows in your table are visible to which users. It provides additional security beyond the table or column level privileges we're used to with SQL. And that means the grant statements, right? You can only grant permission on a table or column level. And that is not fine-grained enough if you have rows in the same table that should not be visible by everyone. So it's a type of access control list for database rows. And its main use case is it saves you application-side security filtering. In the case of the customer that I mentioned, it actually saved them from data leaks because their application didn't even care about these things at that point in time. It's all been fixed now. So when would you use row-level security? One good use case is when you have confidential data. So you would want a way to restrict access to sensitive records. For example, you might be a doctor, but you want your assistants to be able to see the appointments, but not the, let's say, the patient records. Just a random example. I don't know how these things work. Another use case is role or departmental separation. So if you have content that is only relevant to one role or function in your organization or one department. So for example, only HR needs to be able to see the rows that are relevant to HR. Multi-tenant systems is another use case where you have many customers or tenants cohabiting in the same table. And that is a very valid use case, right? Because you don't want to be creating a table for each one of your customers. I remember a use case in the past where an organization did exactly that. And they ended up with 120,000 tables named order and another 120,000 tables named invoice. So they had like 250,000 tables in their database, which drove Postgres crazy because all of these things needed to be recorded in the Postgres catalog. And then you needed to vacuum the Postgres catalog every time you added a customer or removed a customer. So anyway, let's not get sidetracked. Obviously, you wouldn't want your tenants or customers to be able to see each other's data in the same table. Again, finer-grained visibility control. If you want to grant access to specific rows versus specific tables. So let's see exactly how it works. So from the user's perspective, and we're talking about database users here, we're not talking about application users, the rows that they're not allowed to see simply don't exist for them. That is the end result of row-level security. The rows that are not visible to you are simply not visible to you. You don't even know how many rows there are that you can't see. You don't even know that they exist. So there are some key concepts around RLS. Policy is one, where you define policies or conditions for reading or modifying rows. So you may want to base access on some condition that you define elsewhere. Like if this user is a member of HR, then they're able to see. If they are a director in HR, then they are able to read and modify rows, and so on. And also there's a security barrier that doesn't let you bypass RLS with clever tricks like using and abusing views, because you can trick the query optimizer to leak data even when it's protected by row-level security if the security barrier is not defined in the creation of those views. So that's the other component. But how does it really work? So RLS is exactly, I said it's like an ACL, it's exactly an ACL. It's an access control list. This is what it's implemented like internally in Postgres. So internally, what happens is when you run a query that is subject to an RLS policy, you're effectively adding where conditions to the query. So you're saying select from this table where this condition that I defined applies. And the where gets applied automatically because of the policy. So you can define policies that are permissive or policies that are restrictive. So what does that mean? Permissive policies have a Boolean OR between them. So if you have a permissive policy A and a permissive policy B, because it's like an OR between the two permissive policies, right? So if policy B is satisfied, then we don't care about policy A, right? We don't have to check it. You're granted access. Restrictive is the opposite of that. It's a Boolean AND between the conditions. So if a policy C is restrictive, then it doesn't, and it's not satisfied. Policy D is satisfied because both of them need to be true, right? So if policy D turns false, then no access is granted because they're. So let's dive a little bit deeper and see how it's stored internally. We have the PG policy that you can access that has columns like policy relation ID. So that's the table to which the policy applies. PolCMD is the command for which the policy applies. So which command have you written the policy for? Have you written it for selects? Have you written it for inserts, updates, deletes, or all of the above? Do you have, oh, sorry. So the default is true for permissive policies, but you can set it to restrictive. And Pol roles is your access control list. It's basically the array of roles that the policy that you defined applies to. Pol qual is qualification. It's the using clause that you specify when you create your RLS policy. And Pol with check stores the with check clause if one exists. We'll see how that works. So really, how to use it, right? All you need to do is alter your table to enable row-level security. Besides defining the policy, that's all you need to do to enable the policy. Now, the problem with this is that, and this is generally in accordance with Postgres's security by default stance. So you would expect row-level security to have as a default deny access by default, right? So when you turn on RLS for a table, it denies everything if there's no policy defined. It means nobody can access this, right? So the thing that grants access is the policy. So how do you create a policy? Create policy on which table? Customer, for all, SQL commands, it means, for all. To public, and public here is the keyword that means every role in the system. Using, and here's the using clause that we talked about, using this condition. So if this condition is satisfied and it's true, then access is granted through this policy. So what is my condition here? It's customer user equals current user. And again, we're talking about Postgres roles here. And a Postgres role, a Postgres user is a role that can log in, really, so you can use role and user interchangeably. So in this case, whoever is connected as the database user, if their username is the same as the column customer user, then they have access to the data. So it's as simple as including a role name in another column alongside. That is a very simplistic use case, but it works fine. So how does it work? Let's say you select star from customer. This internally turns into something like select star from customer, where customer user equals current user. And current user, as we said, returns whoever's logged in for the session. Okay, so we saw that it works. It's relatively easy to implement. What about the clickbait title? It does suck, yes. But RLS sucks too, and we'll see why. So the thing that's wrong with the way that RLS is implemented, but the thing is, it assumed that your application worked in a certain way that applications used to work like. So what do I mean by that? So nowadays, people generally don't have their data separated by the database user that accesses the data. So it's kind of illogical to assume that separate users of your system or your application will be connecting to the database with a separate database user. Additionally, you wouldn't want Postgres to manage your application's users. So what does that mean? It means you would have duplication. So for every application user, you would need a Postgres user as well. The problem with the roles system in Postgres is that its scope is global. So it is not restricted to a single database or a single table, right? Users can roam throughout the entire Postgres cluster or group of databases. So the scope isn't restrictive enough for if you have multiple databases. The other problem is that the role system in Postgres wasn't designed to give you application-level features. So you can't store your users' attributes or preferences, for example. So again, you would need to store those in your application. And you know, another problem with having this duplication of application user corresponding to Postgres user is the fact that you need to keep these in sync. So whenever you lose a customer or you gain a customer, you have to create or disable a role in Postgres. So that's a challenge as well. Additionally, like, I don't want to say 90% or 99%, but a lot of applications that I have seen tend to connect to the database using a single user. In many cases, it's the wrong user because they connect a super user just to read from the database. So that's another problem. But let's assume that the developers are sane and the DBAs have talked some sense into them and they're using a non-privileged user to connect to the database. But they're still using a single user. So that is useless for applying row-level security because everyone is the same user. So this makes auditing really difficult because you can't tell who changed what and who saw what in the database. And for many use cases that I've seen, changing the way the application works to switch to connecting using multiple users would require a significant rewrite. And in many cases, this isn't feasible for economic reasons, because nobody wants to rewrite an application that works, or because the application is a black box, right? In many cases, the application that your customer is using may have been provided by a third-party vendor, and they may refuse to change their code because they say, you know, we don't care about your Postgres stuff. We sell our software all over the world, and it works fine. So we also mentioned this, aligning application and database users is tedious. You inevitably will end up with a spaghetti of grant statements because for each user that needs to be able to read data from those tables, you would only want them to read from those tables and not access the rest of the tables of your system. Again, remember that the impetus for this talk was the application was badly coded and everyone in that organization's management feared that through SQL injection or SQL injection, however you prefer to say it, some unauthorized person would be able to trick the system into showing them tables or rows that they weren't supposed to see. We talked about synchronization. So what is really the solution to this? So one possible solution is to set variables in your session and refer to those variables in the policy. So you could create a policy, trans policy, for the table transaction for all commands, and you grant it to public, so it applies to everyone, using tenant equals current setting. So current setting returns Postgres configuration settings, but also variables that you've set in your session. So in this case, I have a setting called app.tenant. That is the identifier or name for my tenant. And I'm using the policy to match the column tenant to this value. So in this way, I don't have to connect as role tenant to the database. I can use the existing connection, but I have to set the variable app.tenant to the corresponding tenant value before I can run the query. Which works fine, because if you don't set, you don't get access to anything. So that's kind of safe. Now, why have I prefixed it with app.tenant? If you don't prefix it, it thinks it's a Postgres configuration setting, so you need a prefix to differentiate it from actual Postgres stuff. So this is your variable, and you've namespaced it into your domain called app, for example. So all you need to do is set app tenant equals megacorp, and then megacorp is able to see the rows in the table that belong to them. But what if you are feeling paranoid and you think that someone would be able to set this value anyway, right? Exploiting, I don't know, badly written code or some loophole, and they would be able to guess that megacorp with a capital M is the name of the tenant. So in that case, you would turn it into something opaque like a UUID. The identifier of the tenant, that is. So you create the policy using tenant equals current setting app tenant, But whatever string is stored inside app tenant, you cast it to a UUID. And then you match the UUID to the UUID that you've stored in the column tenant. And that way, nobody knows really what their UUID is. So, and it's really, really, really hard to guess someone else's UUID. So, you would then set app.tenant to be a string that, excuse me, a string that represents this UUID value. And it works much the same way. Remember to cast it, because if you compare a string that represents a UUID with a UUID, that returns false, right? So you need to cast it to the proper type that you've actually stored in the tenant identifier column. Now, another consideration is that you may be using connection pooling. So you may not want to set app.tenant. You may want to set local app.tenant so that it's only valid within this transaction. And it doesn't, so if you're a connection pooler like pgBouncer reuses the same connection for other transactions, then that would leak into other transactions if you set it, because it's a session level variable. So by setting it local, this restricts the scope to the current transaction. So after the transaction is done, it's gone. And it can't leak through the connection pooling mechanism. So, do you want us? Yes, is what I expected. Let's take it a bit further and add role-based access control to our ACL that we've created. So we explicitly define the access control list the way we just saw, but then we add role-based access control on top of that. So we differentiate between tenants and their roles. And it's really the example that I talked about before, that you have access for HR, and you have separate access for Jimmy within HR, or separate access for directors within HR, and so on. So that is based on roles. So how do you implement that? You would add an ACL column to the table. So you would alter your table transaction to add a column called ACL with the type array of UUIDs. Can you guess why? Because we want to store an array of roles that have access to this row, right? And arrays are a great Postgres extension to the standard because you can store multiple values per row in the same column. So this is ideal for this use case because we can store a list of UUIDs that represent roles that have access to this row. Of course, you set it not null, and you set, for sanity reasons, you set the default to not be an empty string, but to be an empty array of UUIDs, right? Because that helps with sanity checking and comparisons. So, seeing that we like using UUIDs for role identifiers, this is what we decided to use, an array of UUIDs to store the access control list and the row-based access control. So instead of setting the tenant, we're setting the roles that are granted access in the ACL. So you would do that as simply as this. Set app tenant roles equals string, and this is how you represent an array in string notation in Postgres. So curly brackets, UUID1, comma, UUID2, close brackets. And then you must remember to cast this into an array of UUIDs, because right now, as a session variable, it's a string. So what would the policy look like for such a thing? So you would create policy, trans-role policy on transaction again, for all to public, using. Now here's the weird syntax. It's ACL double ampersand, current setting, app tenant roles, and we cast it to an array of UUID. What does this syntax mean? The double ampersand basically checks if the first array, our ACL, and the second array have common elements. And for us, that is sufficient, right? If you have even one role that allows you to see this row, then you are granted access to this row, right? So this is what this double ampersand operator does. It checks to see if there are elements in the second array, which is the array of UUID roles, and if it has any elements that are in the ACL. Remember to alter your table, enable row level security, otherwise the policy doesn't apply. So what this policy does is it checks if any of the tenant roles are inside the ACL, but it also gives you role-based access control, because the roles can have attributes that define their privileges. So like Postgres roles, they can be thought of as groups of one or more tenants. Like we said, the group HR, the group directors of HR, and so forth. And you can also define your roles to be able to grant roles to other roles, and then you have an aggregate of the privileges. So it is basically exactly how the PostgreSQL role system works. Why not copy something that works, right? Do you want to dive even deeper? How would you protect this system that you've now built that implements access control and role-based access control from your application that you don't trust? So you don't want your application to be able to go in and change the ACLs by itself, because you've decided that it is exploitable, and therefore it shouldn't know about these things. It should only be granted access to read from the database and write to the database. Because after all, it can connect to those tables and read from them. So what you need to do is you need to hide direct access to this ACL and RBAC system from your application. Why? We said that you don't trust it, or you don't trust the third party, because you're nice that way, you trust your own developers now. So let's assume that for the purposes of this example, we're using a Django-based app. So in the database, on the database side, you would create a role named Django or whatever for the platform that's going to connect to the database, right? Because we have already admitted that we were only using one user to connect to the database on behalf of the application. So you create the role Django, and then you create a table transaction. It has an ID. It has, this is a really simple example. It has an ID, an amount, created that timestamp, and it also has an ACL, right? Because we need an ACL column to implement this. And because it needs to hold a number of roles, it is an array of UUIDs. So to speed up ACL enforcement, we would need an index that supports array operations, right? Because if you have a whole lot of roles and a whole lot of rows in your table, you need some way to instantly find, or as close to instant as possible, to find how you can, which rows you can access. So you would create an index on your table transaction using gin is a good index to use here, because gin supports array ops. So if you use the modifier array ops on the index creation on the column ACL, then that doesn't create a full gin index. It only creates the parts that it needs for array-based operations. And if you remember, the array-based operation that we used, double ampersand, is one of those. So this makes double ampersand, so belonging operations, really quick. So again, on the database side, you would create a table called tenant role, and this is how the role system works inside Postgres. So you have a role ID, a role name, and you would want to add a role description to make it human readable, what this role entails. And this is the Postgres mirroring part. You have another table called tenant role member that records the membership of tenants to roles. So let's assume that you have tenants elsewhere in your system and they have a tenant ID. This is where you make a tenant ID correspond to a role. And this is how you can belong to multiple groups or multiple roles at the same time as a tenant. And then you create an index on tenant role member to speed up membership operations and so on. So the next step is you want to remove the ability of the database user Django to see these inner workings that we've constructed. So the brute force method is revoke all on tenant role from Django. We don't have any privileges on the table tenant role or the table tenant role member. So it doesn't exist for them. But how are they able? You want Django to be able to access the role-based system somehow. You also want to hide the ACL from the application. Because let's assume that someone abusing your application is able to select the entire row. Then they would be able to see the ACL as well, and they would be able to see which other users of the system or tenants have access to this data as well. So in some cases, you don't want that, because it might be confidential information that they're not supposed to know. So you also revoke select on transaction from Django, so you hide every column, and then you grant access back only to the columns excluding ACL. So you grant select to Django on that table, and you only grant access to ID, amount, and created at. So they can no longer perform select star, and they now have to perform select using these three columns that are available to them. Then you create the policy. So create policy trans RLS on transaction using ACL double ampersand current setting app tenant roles equals true. So if any of the tenant roles are found in the ACL, grant access. That's all that means. Remember to alter the table to enable row level security afterwards. So I said that, okay, Django should be able to manipulate the role system, but not through direct access to the tables, right? So you want this to be done in a controlled manner. So what do? You create stored functions that Django can call, that manipulate the role-based access control system, the roles, and which roles get access to which row, but not through direct manipulation of the tables, only through those functions. So you have a function called create tenant role, where you feed it a role name in text and a role description, and it returns the UUID. It goes to that table, it creates a role, returns the UUID of that role to Django. You get another function, getTenantRoles, that when you give it a tenant ID, it returns an array of UUIDs, which are the roles that this tenant has. And also, you need a third function. So this is at minimum, right? So at minimum, you need these three. You need a function called setTenantRoles that takes a tenant ID and a list of role UUIDs, and it sets all roles for a tenant. So that's the minimum implementation you need. There is one more thing that I've just barely touched upon, that for each table, we would require, so for each, in the case of Django, for each type, for each class, right, that corresponds to a table in the database, we would need a function that means add a role to this row, because you want to select specifically which rows you want to grant access to which roles. And correspondingly, you would want to remove role-based access from a specific row. So you need these two functions. And these two functions can belong to some sort of Django automation. For example, you can include them by overriding Django's .save function. So whoever's logged in, when Django saves something on their behalf, then it calls those functions that we just defined through overriding the save function and sets the access control appropriately, more or less automatically. Or you can use some sort of middleware that does this transparently as part of the connection layer between Django and the database. Remember, when defining these functions, we need to define them as security definer, right? Because Django doesn't have access to those tables, but you do. So you grant access through these functions to those tables by allowing security definer. And that means that they get your level of access for those functions. But these functions are written by you, so you control strictly what they do with those tables. Remember to set search path equals public, pgtemp, at the bottom of each function definition when you're using security definer. Because you don't want people to be able to create temp functions that exploit this mechanism to get access, right? You don't want people to trick these functions into executing where they shouldn't be. And that's a good point. Please namespace everything. Don't use the public schema, right? So if you have an application called app, create a schema called app, and create your functions there, create your tables in there. The public schema is more or less deprecated, and you can see that by the fact that in recent Postgres releases, you don't even get access to create objects in public anymore. So let's see what this function would look like. Sorry for the small fonts. So you would, let's say that you have an object called order, and it has a corresponding table called order in the database. So you would create a function called order ACL add, and you give it an order ID and a role ID. And then this function goes and updates, sorry, that's a mistake. It should say order instead of company there. It would update order, set ACL. It would check to see if this is already in the ACL or not, and then it would append it and so forth. So it's a really simple function, and it allows you to add access to a specific role to that order ID. it is trivial to write the inverse function that removes access for that role from that row. Now, a few catches. You need to remember that policies can add overhead to queries. So if you have a complex condition that defines the access criteria, like if this user complicated join with another table, then complicated join with a third table, right? That would slow down your queries because it would get applied for every single row of the table. Remember, we said row-based access control, right? So for every row in the table, it goes and checks this condition to see if it's satisfied, right? So that's going to be a problem if it takes long to check. So what you should do is you should keep your policies simple and very explicit. Remember that the super user can bypass all row-level security checks, so never connect your application as a super user to the database. Remember that the table owner can bypass the row-level security check unless you have specified force row-level security, right? So table owners get to bypass RLS if this is not set. Remember to set a restrictive delete policy because people assume that if you can write to a row, right, that means you can delete it as well. But no, delete operation is quite distinct from update. So you need to remember that people shouldn't be able to delete rows they can read. So let me give you an example. If you have given access for someone to see the row, that means they can delete it if there's no delete policy, even if you've defined an update policy. Right? So you wouldn't want people to delete rows they can read but not update. By setting a restrictive delete policy, that means that no matter which other conditions are satisfied, they're not able to delete. We already said make sure you reset your variables between sessions, especially if you're using pgBouncer or some other sort of connection pooling. Remember that statement mode and pgBouncer will not work. It's like auto-commit, so everything is its own transaction, so it won't work with set or set local. So you can't use this with pgBouncer in statement mode. Fortunately, the primary use case for pgBouncer is transaction mode. So there's no problem there. Apart from, remember that you cannot leak these variables between transactions. So if you're using transaction mode in pgBouncer, remember to set local. Otherwise, if you're not using connection pooling, set is enough. We briefly mentioned with security barrier when you're defining views, because you want to stop any kind of malicious function that defines itself with cost equals 0001, and therefore the planner prefers this function every time, right? You don't want this to be able to trick the query planner into selecting this function instead of something else. Meaning, if you write a function that is preferable to the query planner and your function tries to leak data, right? For example, by instead of reading the rows, because it cannot select the rows, it creates a notice with the values of those columns in that row, right? So it does a raise notice and still leaks the data. Security barrier prevents that, so it doesn't let the function access the data. So you create the view. So the question was, where do we define the security barrier, right? So when you create view, you just specify with security barrier, And that prevents leaks of that type, like people playing clever tricks with raise notice, for example, that can access the values even if they can't select the values. And that's about it. Thank you for sitting through my boring talk. As a thank you, you get some QR codes that give you discounts for my book, PostgreSQL Mistake, and any other Manning product. And you also get a discount from Amazon for the other book. Thank you very much. Questions?
Yep.
Yes.
Any questions there? Give me. Sorry, if you have a question, can you lift? Okay.
So, as far as I understand, can you hear me all right?
A bit closer, please.
So, as far as I understand, you're advocating that we create functions that we then, the code that that inserts records would call those in order to manipulate the ACL, right? If I understand that correctly, right? Like those functions that you mentioned. So, since we're also setting the user roles anyway in the database, can we somehow populate them automatically into tables on insert? Is that something that's possible?
So the question was, do I advocate having functions that manipulate the ACL through the application if we can pre-populate those roles on insert, was your question. Instead of manipulating through the save, yeah, you can do that. But if your application then edits the row, it needs some way to change the ACL if that was the nature of the edit. So yes, you can predefine in Django or whatever other tool or framework you're using, you can predefine it to give specific roles to that row. The thing is, and I have done that, right? We had a record type in this database that was publicly accessible, so every user of the system would be able to read it, and that was created by default when you created a new row. So I don't know if I've answered your question.
In what kind of applications do you think this solution makes sense for? Is this something that you think is potentially a good idea for anything where we have user accounts and data that is only accessible to specific users or sets of users? Or is it more of a niche solution for cases where you really don't trust your application and or your application developers?
No, it's applicable in any case. It's good practice to have this separation. I don't know if you want to go down to the third level of implementation, role-based access control plus ACL plus hiding it from your framework. I don't know if you want to go as deep as that. But if you want role-level security, then that is the, I don't want to say modern, but it's the realistic way to approach it. Now that every application basically uses one user to connect to the database. So I don't think that it's a niche market. If you have like multi-tenancy, it absolutely makes sense to implement this. Some industries that regulate this are finance. The finance industry absolutely requires you to not even be able to leak access to those records to other people. And the same goes for medical records and so on. I don't really advocate using it in every case, but if you have these sorts of concerns, like you're really worried about the consequences of someone inappropriately seeing other people's records, then you should implement something like this.
Okay, so you think like this is a preferable solution to enforcing such things at the application level?
So you can enforce it at the application level, but only if this was a design consideration you had taken into account when you were writing the application. So retroactively, this is the way that you would fit it on top of an existing application. Again, it's a policy thing. So does your organization's policy trust the application with the database access or not really?
Thank you.
So in this example, we don't trust the Django user. We restrict its access. What's the concrete way that the Django user in like a given session and context knows a given UUID for a user? I'm imagining an application where like...
Sorry, can you repeat that?
How does the Django user know like a particular UUID to even set in the session?
It calls the function get roles. And then if it has some sort of description of the role somewhere that corresponds to a text-based description, then you can match them with the roles, with the role UUIDs in the database.
Oh, sorry, I meant like tenant IDs. How does it know like what a tenant ID is? Is there like a layer?
Yes,
of locking that?
the Django code knows what a tenant ID is. It knows what a tenant is. So that is not hidden from Django. The role-based access control part in the ACL is hidden from Django. But Django understands tenant ID. Yeah, I should have made that clearer, that it's already implemented. And you may not call them tenants. You may call them users or customers or whatever.
I guess what protections are in place to stop just the Django user from enumerating all roles by calling these functions on like every single tenant if it knows what all the tenant IDs are?
So your question is, how do we stop Django from abusing these functions?
Yeah, or is there some sort of enforcement mechanism or auditing, given that we don't trust the Django user to begin with?
Yeah, stopping it, not really, but I would assume that the code wouldn't be coded badly enough that it would let you perform a brute force loop over the entire set of tenants. And again, it wouldn't expose the information that links the records to the UUIDs, right? Auditing is definitely something you should consider in high security environments. So you can implement, you can add an extension like pgaudit that records all accesses to the tables, and then at least you're covered in the legal sense that it may have happened, but you tracked it and you stopped it and you have the evidence.
So maybe a follow-up to this question. So a lot of systems today use JWTs, Java Web Tokens. So these are signed JSON that tell you the user and the audience, right? Like the kind of the roles that the user is authorized for. And if you could have Postgres check those, then you wouldn't have to trust the application. The application would need some source that signs users JSON tokens, and then the application just passes them to the database, which verifies them.
Yeah.
Did you see some way for applications to set these tokens in and for Postgres to verify them when they when?
Yeah. So the question is, can you use JWTs for this thing? Can you grant access to specific JWTs, and when Postgres sees them? Right now, Postgres doesn't have a JWT. I'm looking at Magnus there. It's not in the plans to implement JWT authentication, right? Okay, so what Magnus said for anyone watching at home is you could implement this in Postgres 18 because of the flexibility and authentication methods, and 18 isn't released yet, we may remind you, but a plugin for checking JWTs is not implemented yet. I would add that this JWT technology is mostly is mostly meant for HTTP requests, right? So it adds a lot of traffic to your network stream, and I'm not sure that you want that between your application and your database. You want it to be as lightweight as possible.
All right, so first of all, free advertisement. I want to start from the end. So this is a super awesome book. I did technical review for this, and you know what? I know a thing or two about Postgres. In each and single chapter, I found things which I did not know. So I cannot recommend it more. When it will be published, I want to make sure all of my DB team has it and use it. It's just super awesome. So use this discount. It's like great. Okay, that's number one. Number two, yeah, thank you. It was super interesting, and like I know the problem intimately, and it's very, very cool approach to solving it. Like I actually wanted to say about this, like you want to avoid this multiple backs and forth, so basically you answer this. Like one little comment, like I know you know, but for like public education. So when you do security-defined function, which is, I also use them as a great way to give users exactly what they can do and not a centimeter more. But we also need to revoke execute from public because functions, so functions by default are executable by anybody. And normally you kind of limit them because users have limited access to underlying objects. But when they do security definer, if the first thing you would not do revoke execute from public, then anybody can become super user. So like what Jimmy showed, just security definer, revoke from public and grant only to the user who needs it.
Right.
Yeah. An ideal way would be just to make the applications use functions, which I succeeded twice in 40 plus years of my career, because then it's kind of easy. You actually can control it like inside the function, and you do not need to do this checks, and then you also reduce overhead this way, because then you can optimize it the best way.
Yeah.
But yes, this is the next best way.
I think we've reached a disconnect between developers and database developers or database administrators that we probably should not let developers include SQL statements in their code anymore, right? That is bad practice.
Yes.
So whenever you want to expose data from the database to your application users, probably the safest way is to define a function. And the function may return a table, right? You can define functions that return tables or sets of records. And they can use them exactly in the same way that they would select directly from the table. But nowadays, that SQL gets a bad rap, and people say, oh, it's obsolete, or it's an old language, and we're TypeScript developers, we don't need to care about that. And then they try to select something from a table and construct a horribly mangled query that takes 30 seconds to run. With the next release, where the previous release only took 1 millisecond to run, and you try to figure out what happened in your database and why it broke, right? It's probably best, if not for security reasons, at least for performance reasons and reliability reasons, to expose data access through functions. There's a question in the back.
I just wanted to add on to what you said, and then I have a question. It would be great if developers actually learned SQL instead of relying on ORM abstractions. It would make everyone's life easier, even if you are writing functions to return data.
It would be great, but they are actively being told that this is the domain of the DBA. You shouldn't care about things like that. And then they go out and they get a job in the real world, and they are expected to write SQL queries.
Yeah.
And they inevitably do a bad job at it. You can read books, you can read blogs, you can look it up on Google or Stack Exchange, or Stack Overflow, but really there's no substitute for experience. So you should probably ask your DBA if you're a developer and you're not sure how to bring stuff or write stuff into the database, just fire an email or Slack message to your DBA to double check if that's kosher or not. And that eliminates 99.9% of disconnects and problems.
Don't be afraid.
Don't be afraid of the DBA, who's usually a middle-aged, bearded man who's almost always angry.
All right, now my question. Sorry.
Sometimes female angry person. This was a jab at the lack of diversity in our circles.
Which is fair.
Did you have another question?
I did. I actually had a question. So in the wild, in actual reality, when you're seeing these, where does the evaluation of the ACL take place in the query plan?
Sorry, your question was how long the evaluation takes?
Yeah, yes, because most people aren't trying to read the entire table. I imagine there are other indexes at play.
Yeah, the index helps a lot. Yeah. So it takes like fractions of a millisecond for tens of millions of rows.
Great, cool.
So yeah, that's the job of the index, right? As someone pointed out earlier today, the job of an index is to pre-calculate the output of this function. So you store the output of the function that compares this to that, and you have it ready for all those rows, instead of running it for every single row.
Okay, another question?
Hi, I was looking at the use of the UUIDs, and it jogged my memory about UUID 4 versus 7 and the different kind of index impacts. Is there any benefit to using time-sorted UUIDs if, like, let's say we have an example of some other database user writing lots of rows, and
so
then you
the
have something
question,
reading?
Sorry, did you have anything?
Yeah, which, like, is there any benefit to using UUID v7 for this? And if so, like, do we need to change what kind of indexers we're using to make this work better?
Right, so the question is, well, first of all, UUID 7 isn't available in Postgres yet, right? So this is a feature that's getting added in Postgres 18 that's coming out later this year, fingers crossed. So is there any benefit to using a time-based UUID like UUID 7 versus a truly random UUID, a fully random UUID like UUID version 4? Well, the answer is if you want to do something with your identifiers, like sort them by time, then yes. It would give you a way to encode secret knowledge into the UUID, like the creation date, for example, of that user, or the creation date and timestamp of that role. And it would let you sort the UUIDs by time order, let's say, or numerical order. Is that something you would need to do? Probably not, because you would already have a creation date for your customers or tenants anyway in that corresponding table. So it wouldn't be bad, it wouldn't add significant functionality in my opinion either.
Okay. Everybody, thank you very much. We give a nice round of applause to Jimmy here. Appreciate you coming out and talking. Thank you. So really quick, just to do a quick schedule check. Anybody here for the Colin Charles talk on understanding Postgres for the MySQL developer? That had been canceled. So if you're looking at this schedule, it is wrong. So thank you. Okay, everybody, while Matthias is getting his system all set up here, we had a little bit of a long one last time. I apologize for that. I do want to go ahead and reread a little note here. This room has been sponsored by Quest Software this year, so we want to give them a plug, a little shout out for helping us out here. Postgres is great, but managing database growth and scaling without downtime can be tricky. That's where SharePlex comes in. Real-time replication, zero downtime migrations, and easy scaling. And with Foglight, you get full visibility into performance bottlenecks. If you're looking for ways to make Postgres work smarter, not harder, talk to them after your sessions. Okay, thank you.
1, 2, 1, 2. Does that work?
Yep.
All right. Yeah, sure.
All right, everybody, thank you. Welcome back, SCaLE 22. Our talk today, our next talk is Introduction to Vitess, Open Source Sharding Framework for MySQL. It's going to be presented by Matthias Kralls. Matthias is an enterprise customer engineer with PlanetScale, supporting large enterprise type customers running MySQL at scale. In today's talk, Matthias will walk us through the steps to migrate your current MySQL-based solution into Vitess. After the talk, we will have time for a Q&A session. I ask that you please hold off. I'll run over to you with the microphone. We are recording. We want to make sure we get the audio good. All right? If you don't mind, let's go ahead. Welcome, Matthias. Thank you.
Thank you very much. For anyone that was expecting Colin Charles here, Colin couldn't make it. His plane got canceled, so they asked me to step in for him. I feel a little bit on enemy territory, like I'm giving a MySQL talk in the Postgres room. It's not entirely what I had in mind, but while Vitess is written for MySQL, some of the concepts can easily be ported to Postgres as well. It just hasn't been done yet. I think it's a matter of time before someone else will start doing it. Vitess itself is really specifically written for MySQL. So porting this software to Postgres is going to be hard, but the concepts are still really valid for Postgres as well. So who am I? My name is Matthias Kralls. I live in Belgium, in the beautiful city of Ghent. I have a bachelor's degree in computer science. I've been a Linux user and administrator for over 25 years now. I started my career as a PHP developer, which is also the reason why I landed in MySQL land. Because back in the day, everyone running PHP was doing MySQL. I do not have anything opposed to Postgres. I was just MySQL user and became a DBA after that. This is my third year at PlanetScale. I'm an enterprise customer engineer, as I was introduced. I work with our large customers to do their migrations and help them set up for success in PlanScale. And I have one son, Leander. About PlanScale, like we are a database as a service solution in the cloud based on Vitess. PlanScale was founded by the co-creators and maintainers of the Vitess open source project after the project was donated to CNCF by Google. About Vitess itself then, this is an open source database technology that was created at YouTube back in the day because YouTube had all kinds of scaling problems running their database. And so they needed to come up with a solution to deal with that. They wanted to keep using MySQL. And so Vitess was a layer on top of MySQL that they invented to solve all the scaling issues. When Google decided that they wanted to push Spanner in their internal infrastructure, they donated the project to CNCF because it had really much value for the community. And other massive companies like Slack and GitHub are using it for their data stores. Slack is fully on Vitess. GitHub is not fully on it, but they are migrating towards it. These are some of the logos that are using Vitess in production. So PlanScale is one of them. We don't own Vitess as PlanScale. We are the biggest contributor to the project because we have a lot of the maintainers of the source code working for us. But it is owned by CNCF and it is developed in open source first. Even though while PlanScale is a database as a service offering that's like not free, it is still, we are still working on Vitess in the open source. The agenda for today, I'm going to talk about the architecture of Vitess. Then we're going to see about MySQL compatibility. Then I will introduce you to vReplication, which is our way of doing migrations and all kinds of cool operations. And then at the end, we'll talk about online schema changes, which has been a pain in MySQL for a long time. And then at the end, I will also talk briefly about automatic failovers. So architecture, what is Vitess? Vitess is a cloud-native database, but in a different way than what you would see in something like TiDB or CockroachDB, which were specifically written for the cloud. Here we are using an existing database technology, MySQL, to run in the cloud. And actually, Vitess was cloud-native before the term cloud-native existed, because it was invented and created at YouTube, and it had to run on Borg in Google, which was the predecessor for what became Kubernetes. And so, in a way, the first releases of Vitess predate the releases of Kubernetes. And so, before the word cloud-native, which was introduced by the birth of Kubernetes, Vitess was already cloud-native ready. It's massively scalable. There is, to my knowledge, no limit to how far it can scale. Typically, we talk about shards, and it's a 64-bit unsigned integer. So that's the number of shards that you can theoretically create, which will get you pretty far. I don't know anyone coming close. It's highly available, obviously. We don't run anything on a single component. Everything is set up to be high available with failovers and spares and everything ready. And it's fully MySQL compatible. It's not 100% MySQL compatible, but we're trying to. So if you ever run it and you find a bug where it's not fully doing the same thing as MySQL, do open a bug report and our team will look at it to try and fix it. Some important concepts in Vitess world that you will need to understand the next slide is a key space. What we call a key space is mostly a contained database. And then a key space can be sharded or unsharded. Like uncharted, then you just have one set of servers serving that data. If you shard the key space, then there will be multiple sets of servers. And then a topology server is basically where we store the metadata of what are the components of the Vitess cluster. That topology server itself is highly available, and all the components check the topo server to find out where all the replicas are, where the primary is, which other components are deployed in the ecosystem, and so on and so on. So this is a very complicated slide at first. This is the Vitess architecture. You see here a dotted line. This is, on that side is your application. On the other side here is the Vitess deployment. And what you see here is a load balancer, because you should never set up one component of each. You should always go through something to distribute the traffic. And the entry point to Vitess is VTGate. This is our gateway or proxy server that we deploy. And this is where you connect to with your application. VTGate has several protocols that it supports. So for one, it supports the MySQL protocol, so you can connect to it with a MySQL client and just run queries as you want. But it also supports a gRPC endpoint, which was basically what YouTube was using to query the database. And which is also the thing that we at PlanetScale use. What we did at PlanetScale is we added a component before. Where's my pointer? My battery ran out? Okay. We added a component as a load balancer on our end, which we call the edge layer, which terminates your MySQL connection and then takes your queries into the Vitess ecosystem to VTGate over gRPC. But you can just deploy VTGates and set the load balancer in front of it and connect your MySQL clients. Then if you go on, follow the lines here, you end up with VT Tablet. And this is basically what we call our sidecar to MySQL. In most deployments that I know, it's actually the other way around. We deploy tablets, and then we have we have MySQL-D as the sidecar to VT Tablet. But MySQL-D is the thing that stores your data. So in general, in the MySQL talk, you will say that VT Tablet is the sidecar to talk to your MySQL and relay the data to VTGate. What you can see here, this thing is what we would call a key space. And a key space then consists out of at minimum one primary VT tablet with a MySQL D attached to it. And then you can add as many replicas as you want. You can have additional types of replicas for big data or for ETL workloads. That's all supported. But the minimum setup is one VT tablet being your primary to talk to. What VTGate will do, if you send it a query, it will parse your query. It's just like PostgreSQL, it's a layer 7 proxy. It understands your query, it will parse your query, and it will then determine based on your sharding schema where to send the query. If you have a query that should be serving you data from multiple shards, it will send the query to different shards, and it will aggregate the result set on the VTGate level. So what you will see if you do on the sharded table, if you do select star from table, it will basically query all your shards, which we will call a scatter, and it will gather all those results back to VTGate and aggregate them. Obviously, there's a few protections on the VTGate layer to protect you from shooting yourself in the foot. If you would select 1 billion rows, that would easily overflow the memory on your VTGate. So there's a limit on how many rows it will give you back. That's a configurable limit. I think by default it's set to 1 million rows, but you can set it higher or lower depending on your the specific use case. So what we recommend is that you tune your schema in a way that you would target a specific shard for your query. Like if you would shard by user, we would recommend you to keep all the tables that are user related on the same sharding key. So if you then join between those tables, you can push that join just down to MySQL, which is what it's good at, like joining and serving you data. Then you just pull that data from that shard and give it back to your customer. On the side here, you see the topo server. There's 2 instances drawn here, but you should scale that out to at least 3 to have partition tolerance. Like if you lose 1, is it network partitioned, or if it's it doesn't know. You should have a quorum, so at least 3 is the best practice. We support Zookeeper and etcd. We used to support console as topo server, but I don't think we do that anymore because there were some limitations. But we at PlanScale, we use etcd as the topo server, and that's also the most recommended. But I know for sure about some of the big users that are using Zookeeper as well, so that's also supported. And then the yellow boxes here, they're optional. Well, optional, yeah. Components. VTCTLD is a control plane daemon that basically allows you as a DBA to interact with the cluster, to run some commands, like if you want to create a key space, at some point you need to do that. And VTCTLD will then talk the right language to the topo server to make sure that all the necessary records are getting created. If you want to add a tablet, that's also done through VTCTLD. But in general, if you would like to run this on your own, you would probably want to use an operator that does all those operations in the back for you, and that will then interact with VTCTLD to create all the necessary components. I will go into a bit more detail about VTOrg later, but that's our orchestrator implementation. It is based on the original orchestrator, but it is for high availability of your MySQL cluster. So if you have a failure on your primary, VTOrg will be the thing that does the promotions to make the primary highly available. And then finally, you have VTadmin, which is an admin interface that is a nice GUI for the cluster. That shows you a lot of information about your deployment. It used to be included in VTCTLD, but that was not the right place to do that. And so a few years ago, by now, we created VTadmin, which is now the default to view the state of your cluster. Any questions so far about architecture? Did I miss anything? Okay. Then let's talk about MySQL compatibility. Vitess provides you an illusion to your application. It poses itself as a single database server. While there might be hundreds or thousands of servers in your deployment, you could still run a select star from table, and it would look like you are querying one big data server, but it's not. So we support MySQL 8.0 and above. We dropped support for 5.7 because that's end of life. So I had to fix this slide this morning since my last presentation of this. 8.4 is supported as far as I know, but you still need to enable the MySQL native password plugin because Vitess does not speak the caching SHA-2 yet, but they're working on that. And so it looks like a single dedicated connection to MySQL, but in fact you basically connect to VTGate, and then VTGate will take your query to all the MySQL servers that it needs to. Vitess needs to deal with all the different database frameworks out there, ORMs. If you have legacy code, if you have third-party applications, it needs to fully support the MySQL syntax. That's why I'm saying if you find any syntax that's not supported, open a bug report and we will try to fix it. Recently, I opened a bug report with the developers, and they found out that MySQL itself is doing something against its own protocol. And so then they open a bug upstream to MySQL to fix the bug in MySQL. That happens, but we try to do the right thing. That brings us to vReplication. vReplication stands for Vitess replication. MySQL, by its own, is known for its replication features. That's how it came to be useful at scale. Like you can use replication to scale out your reads. And Vitess has an abstraction layer above that to support these three major use cases. The first use case is the migration to import data into your Vitess cluster, which is what we will be talking about in a bit. You can do resharding or sharding or resharding using vReplication, basically move data around to different database servers. And then you can also do materialization workflows to improve query performance. The example I always give when talking about materialization is imagine you have like a web store, a web shop, where you have different currencies that you support. You support euros, you support dollars, you support yens or rubles, doesn't matter. Those are stored in their own table, and you join that table with your sales, so you can then know what currency you're deploying that in. So if you do not materialize this table and you shard your sales table, you would always have to do a combination of result sets in VT gate level, because you would have to query the currency ID, like this currency ID is that name and blah, blah, blah. And then you have to query your sales, and then you have to merge that together. What is much more efficient is that you could push that join down to MySQL, which what it's very good at. So you materialize your currency table on all your shards. So all the shards have the same data for that specific table. And you can then join on the MySQL level without needing to do cross-shard queries.
In that case, it has to be with like a realization, or you can specify a set of tables that are with all the shards.
Yeah, you specify the tables that you want. Like you specify them. I didn't go into detail about how we decide which tables are where, but that's what we use the V schema for. So that's a JSON file that defines which tables live where and on which field they are sharded. Like you define a primary Vindex, which is then your sharding key, and you define the function you want to use to shard that table. And then if you have a table that you want to materialize or want to use as a reference table, you define that specific table as a reference. And then if it's a static, then you have two options. You have a static table that never changes, so you just deploy that table on all your shards and be done with it. If it's a table that you can change, like the currency table you could change, there could be another currency added, your application would talk to the unsharded key space where that data is stored, but then the materialization workflow would materialize the changes as well to your different shards, so they keep actually in sync with the source. So, importing data. This is one slide that takes weeks of work sometimes. First step you do is you need to bring your existing database into the Vitess ecosystem. So what we call, you create an external key space with a VT tablet pointing to your existing MySQL server. So if you have an RDS server or a MySQL server anywhere, you basically create an external VT tablet that is not, we call it an unmanaged tablet, that is not managing its own MySQL. It just connects to the MySQL that's there, using the credentials that you provide to it, and it becomes a key space in the Vitess ecosystem, and you can then use all the Vitess tools to talk to that key space. You can route queries to that key space, like if you tell By default, if you create then a move tables in this case, you can, it will create a set of routing rules to route the traffic that you're sending to the VT gate to the source key space. So if you connect to VT gate, you will be querying the source database where you are replicating from. In the background, what move tables will do is it will start copying your data. I will go into a bit more detail in the next slide on how it does that. But it's basically a vReplication workflow that moves your data into Vitess. It basically copies from your source into the target, shards it's on the way if you need that, if you configure that. You can do from unsharded import to sharded import or to unsharded import. It doesn't matter. You can do whatever you want with that. Once your copy is done, we have a tool called vdiff to verify that the data in your source database and your target database is actually binary the same. It will do a checksum on a row-based row level to validate that the data is in sync on the boat. Yes. So that's why it does it on a row level, because on a row level you need to know from the primary index where your data on which chart it lands. So on the source, it's one big table. On the target, it's many small tables, but you can still verify that the records are in sync. And then you can migrate your data, your connections or your queries to go to Vitess on two levels. You can switch read traffic separately from write traffic. So if you switch read traffic, the only thing it does is it modifies the routing rules it created at the start of the stream to start sending anything that's at replica or at RD only to go to Vitess, and anything that targets your primary will still go to your source. If you do a switch write, it will also modify the routing rules for the primary tablet type, but it will also automatically reverse your application stream. So you are migrating from, let's say, RDS into Vitess. You're copying data to Vitess. At the moment you switch writes, you're copying data back to RDS. So you have a reversible migration. Like if you migrate your writes, you start writing on the Vitess side. And if you then notice, oh, this is going wrong, this is not what I expected, you can go back without any data loss. It will replicate back.
So that's obviously only until the migration is complete.
Yes. At the end, all the way at the end of the migration, you decide what you do. Either you reverse your traffic to go back and you fix your issues and you try again. You can flip back and forth as many times as you need. At the end, when you're done with the migration, you complete your migration, and then it detaches the old cluster from your Vitess cluster, and then you can decommission anything that's talking to the old cluster or the old cluster itself. And so this is what we mean here, full rollback, that you can reverse replicate back to the source database. So if you want to do vReplication with regular MySQL as a source, regular MySQL or RDS, you need binary logs, because that's the thing that allows you to do delta differences between the two servers. It's basically a stream of changes, and you want to get all the changes that are made on your source to the target. We recommend to copy from replicas. If you want to do that, you need log replica updates configured. Obviously, because otherwise you don't get the updates from your upstream primary in the binary logs on your replica. So if you want to do that from a replica, that's recommended. If you're copying from your primary, then the only thing you need is binary logs itself. Binary log image format needs to be row, and image needs to be full. This is because Vitess reads the event, and it does not apply binary log events, but it converts them into actual SQL queries. Like it converts any inserts back to an insert, an update back to an update. So it basically runs the queries that your source has run on the target. The copy of the data happens in 2 phases. You have a copy phase, which is basically a long-running select. It does select star from table, and it starts streaming that data on the primary key order to your target, to your Vitesse. By default, it does that for 1 hour periods. You can configure this setting like vReplication copy phase duration. You can set that higher or lower depending on what you need on your cluster. But it will run the copy. After the 1 hour, it will do a catch-up phase. And it will catch up all the differences that were written on your cluster during that hour of copy. If you this was implemented this way because if you would do a long-running copy for days or weeks in a row, and then you end up your binary logs being purged, you cannot continue anymore. So that would be a bad idea. So that's why they do with smaller iterations. If after an hour the table you're copying is not fully copied yet, it will continue after the next hour from the primary key where it left off. So it stores the primary key until this primary key I copied. From there on, I will continue the next copy. So the next iteration will be select star from table where primary key is equal or larger than this one. And then it will copy the rest of the table in the same primary key order. And then if it's taking multiple iterations of that, it will just keep iterating between copy phase and catch-up phase between the two. We do have some throttling to protect your source server. We have a throttling on the history list length. So because this creates a long-running transaction on your source, if you have a busy source server, you can see the history list building up, and that will have all kinds of negative effects on your performance. So if you, this is the setting we use, and the default is 1 million. And that's 1 million entries in the history list. Then it will wait until for the next copy iteration. It will finish the current copy iteration for the 1 hour, but it will wait and not start a new one if it's above this threshold. If it then catches up and goes below the threshold, it will start catching up again.
So a million, history list length of 1 million is typically going to show considerable degradation on a lot of primaries?
Yes.
I assume that's configurable?
That's the actual configuration setting that you have to specify to your cluster.
And do you play with the cleanup threads by any chance after? So let's say you do the copy, and let's just say it got to be 1 million or 900,000, whatever. So the number of copy threads, the number of cleanup threads.
We do not mess with that directly. That's up to the source DBA to deal with that, because basically we are not managing the source database. So we just check the list length, and if it's above the threshold that we configure, we will not continue. Same thing with replication lag. If you're copying from a replica and your source replica starts lagging behind, we will not continue will not start a new copy phase when it's lagging more than 12 hours. To allow the cluster or the server that you're copying from to catch up, use all the resources it has to catch up replication.
So these throttles, they're during the 1 hour, right?
Yes. Well, they are checked at the start of each copy phase. So if a copy phase is running, it will keep running.
So only at the beginning?
Only at the beginning. So, and then if it's blocked by any of these two, it will go on a schedule to recheck those settings, whether it's lower than what you.
So if the history list length, let's say, jumped to 2 million, 3 million during the copy.
You would only notice after the 1 hour copy. So that's why we are conservative on the duration. So we use 1 hour. If you would see in your history list length, you can also manually stop the copy. Like if you see that it's building up, you can just call workflow stop. It will stop where it's left off, and then you can restart it once you are okay to continue. And then finally, at the end, if all the tables you wanted to copy are done, fully copied, the entire table copied, then it will just stay in the catch-up phase, and it basically will act as a replica, reading the binary logs, applying until you decide to do something with that stream. The copy phase, we recommend to use a replica.
Yeah, no, but you have requirements for large tables for a specific primary key, like unique
The only requirement is that it needs to be a unique key or a primary key. If there's, that's okay. There's no limitations there. What we saw at some point was that Vitesse did not force the primary key order in some cases. And then what you get is you do a long-running select, but it starts buffering. And then it only starts sending the data after the buffering has complete. And that was the buffering was taking longer than 1 hour, so it wasn't progressing at all. So it took us a while to figure out what that was. And what we now did in the copy phase query is we force index primary key. So we force the order of the primary key. And then you can always rely on that it's serving you in primary key order, so it doesn't have to do in-memory sorting or any such thing. So that's how we solved that issue. But it was an issue at some point with a large data set. Especially there was a table with combined primary key, and there it was an issue. And MySQL chose the wrong key for the query. But we figured that one out, and if you force the primary key, there's no issue. I was specifically not mentioning Aurora earlier. RDS works, but Aurora is a different beast. By default, Aurora replicas have no binary logs, and you cannot enable them. So what we've done for that is we basically set up an async replica to the Aurora cluster, being a new Aurora cluster. Like you set up a secondary Aurora cluster from your snapshot backups that Aurora automatically makes. You set up binary log replication from your original cluster, and then you can use the primary of that replica cluster as a replica tablet. Even though the cluster, the instance you're connecting to at that point in time is a primary, you are connecting a replica tablet to it, so it acts as a replica to the Vitesse ecosystem. The server UUID in the GTID is the same for all nodes on the source cluster. So if you have a failover on the source Aurora cluster, that just works, because the UUID doesn't change, and you can just continue replicating where it left off. Like the GTID that it last saw, if the failover is done, you will be disconnected at some point because the server goes down, a new one comes up, yada, yada, yada. But you can just continue replicating from the original Aurora cluster. If you don't have GTIDs enabled, and enabling GTIDs requires a full Aurora reboot, which is plain stupid. In MySQL it's 3 commands, but in Aurora it's a full reboot. There is an option to do this, craft this manually. For a customer very recently, where they set up this this replica cluster, the replication was never catching up. It was only going farther and farther behind. And so we were like, okay, how are we going to do this? It was a sharded migration that we were going to. So we basically set up the replica cluster as a stale copy of the data. And we did the copy phase from that cluster. And at the end, it said, I'm fully in sync. I have everything that you've written on the source side. OK. We then added a new tablet pointing to the original upstream replica. We did a tablet externally reparent operation in Vitesse. So we basically said the primary that we were connecting from, the stale one, is no longer the primary, but it's now a replica. And the original primary, the new primary, was the replica that we just created. It's the upstream primary. And suddenly, Vitesse noticed, like, hey, I am 5 billion transactions behind. Let's start replicating. And it caught up those 5 billion transactions in about 12 hours. While Aurora to Aurora replication could never catch up, in about 12 hours we got 3 days of binary log delay caught up, which was really impressive. And then to do those operations, if you don't have GTIDs, you need to then find the right file position for the replica you're at. You can then update your V replication position to the position that you got here, and then you set your tablet type to primary, and then you restart your V replication workflow, and you can then replicate from the regular binary logs. Another fun thing to do is, what if you want to migrate from a sharded Vitesse? Like you have a sharded Vitesse on-premise, and you want to migrate to the cloud. Seems like a reasonable ask. The problem in this migration, this specific migration, was we do support something called mount and migrate. Basically, we mount the data directory from the source, we migrate that over into our Vitesse. But that's non-reversible. The customer in this case wanted to have a fully reversible migration so they could test. Important in shard-to-shard migration is that you have the same sharding schema on both source and target. So you have a sharded Vitesse already that's working, that's serving traffic. You basically, your new environment, you copy the same setup. You create the same setup, same number of shards, same sharding keys, all the same. And then you can add a VT gate flag, enable partial key space migration. Normally, if you do a migration on Vitesse, you migrate the entire key space at once. But if you want to go shard by shard, you need to do partial migration. So some shards are still talking to the old cluster, some shards are talking to the new cluster, and that's what you need. This does have a performance impact on VT gate, obviously. That's why we don't enable that by default. You need to specifically tell VT gate, like, I want to do this. And then you can do basically move table streams per shard. You just move shard by shard, and you can switch them over back and forth individually. You can test. There's no big bang in this situation. We added something called shard routing rules for this specific use case. Like I talked about routing rules initially, where you direct to which key space your queries are going, to the source key space or to the Vitesse target key space. In this case, these routing rules are defined on the shard level. Like you can say shard A goes to there, shard B goes to there. That's just an extension to the routing rules. It was easier to implement different type of routing rules than to hack that into the existing routing rules. So that's why it's different. And we executed this recently. There's a blog post on the PlanetScale website about the cache app migration. This was 256 shards at that time. It's not the hard limit, but it is where we've done this with, and this requires quite a bit of manual work from your operator to deal with those migrations. And at the end, you have to clean up things yourself, like all the streams. You need to clean up yourself. It's a number of commands on the VTSTLD that you need to run. A number of commands on the VTSTLD endpoint that you need to run. I have 10 minutes. Okay, perfect. Another thing that we're currently working on is multi-tenant migrations. And that is when you have multiple identical schemas in your source database. Like we are currently migrating a customer that managed to create 18 million tables on Aurora because they have several customers, and each customer has approximately 100 tables. So yeah, 18 million. It's a bad practice in general to do that. But yeah, they luckily had a unique identifier for all the tables that's immutable. Like they sharded that per app ID, like tenant ID. Their app ID is a tenant. And so basically, we made sure that that identifier is in all the different tables. We create an external key space for each of the source tenants. So 18 million tables, 100 tables per tenant. That's like 180,000 key spaces. And then you specify the tenant field in the V schema. Like you specify which column name you want and what the type of that column is. And then your queries will automatically start including where the tenant ID field and the value of the tenant that you specify in the move tables command. So in the move tables command, you specify this specific migration will migrate this tenant ID, and then it will add that where clause to all the queries in the migration, and it basically merges hundreds or thousands or hundreds of thousands of schemas into one sharded key space. This is, again, having a key space routing rules, because we didn't want to create routing rules for 180,000 tenants times 100 tables. That would be massively inefficient. So we basically create per key space, which is bad enough. We also added an option to create the move tables for a specific shard, because they are sharded on their tenant ID, and so you know at the start of the migration to which shard your migration will be going. Like if you would migrate this to a cluster with 1,000 shards, you would have to create 1,000 streams per tenant, but 999 of those streams would be idle, doing nothing, because it would still go to one shard. So you can specify also the shard it goes to. These are extreme things. That's what I'm working on at PlanScale in Vitesse migrations. So yeah. Then quickly something about online schema changes, which has been the bane of the existence in MySQL. It was always blocking. Like if you on an old MySQL server do an alter table, it will create a shadow table, lock the original table, copy everything over, and then unlock it again, which is bad for business because you're blocking the table. It's resource greedy, it's not auditable, you cannot stop it or continue it. That was a big issue. The MySQL community has made different workarounds over the years to start dealing with these shortcomings of MySQL. First you had Ghost, you had PT Online schema change. They're all external tools, and you need to know a lot operational knowledge about the environment. And it takes control out of migrations of the developer hands. Like the developer needs to talk to the DBA to execute the migration, which is a pain. The DBA is overburdened already with other tasks. So what Vitesse does basically uses vReplication to migrate inside a key space. So you set your DDL strategy to online, you make the change, and immediately, like instantly, it comes back with a UUID. That is your migration UUID, and in the background, it will start doing your migration. There's an option that you can give to online to postpone cutover. Like by default, it will do the migration when it's ready, when it's copied all the rows over, it will automatically flip the tables and clean everything up. You can postpone that migration, so you can control when it does that. But by default, it's not. By default, it's just going as fast as it can. But you can configure that. And basically, while this is running, you can go grab coffee. There's nothing else you need to do. No, it's fully vReplication based. So it uses the same the concept that we talked about in move tables. Basically, it doesn't move tables inside the key space. It creates a shadow table. It runs your alter statement on that shadow table. And then it starts doing a copy phase, streaming binary logs, again copy phase, binary logs until the whole table is configured. But there's more. I talked about move tables being reversible. This makes schema migration fully reversible because it can do the vReplication, again, to the other side. Like you have your source table, copying data over, you flip them over, and you see, oh shit, it's not working. You can reverse them. And it will keep both tables in sync until you break that replication up. So it keeps the two sides in sync. So if you want to revert your application, you just do revert Vitess migration, the UUID you got, and you got another UUID because it creates basically a new migration. But there's also the option declarative, like if you do not want to write alter statements, you can just run a create statement again for the table you already have existing, and Vitess will figure out the change it needs to make. Easy as that. So using online schema changes in Vitess puts the schema changes back in the hands of the developers. As a DBA, you don't have to bother anymore. You just create it. It's easy to run, easy to revert, and due to the robustness of your application, it can even survive a primary failover in any type of outage. Like before we had this, we were using Ghost in Vitess, and if you had a failover, you had to restart your migration. Simple as that. You couldn't continue. Using vReplication, it's so robust, you can just continue where you left off if you have a failover. That brings us to failovers. Orchestrator, many MySQL users will know about Orchestrator already. It's currently supported by Percona. And what we have done in Vitess is we created our own Vitess component we call VT-org, based on the original Orchestrator. But as you saw here, there's things it needs, well, it does discovery, visualization, monitoring, and refactoring. Discovery, VT-org does not need to do because the topo knows all the components already, so it doesn't need to discover anything because it's already there. Visualization, the Orchestrator UI is very nice, but it was designed to display pretty complex topologies. Like it was developed at Booking. At Booking, you can imagine they have large topologies with many servers. In a typical Vitess topology, you would have many clusters, many small clusters, but only one primary and two replicas. So the visualization doesn't make much sense there. So we basically replaced that by VT-admin, where we display this in a different way. Monitoring of the topology is very relevant, and the refactoring of the topology also. That's what VT-org does. So the refactoring will automatically update the topo. If you would run old Orchestrator against Vitess, that would work, but you would have to create hooks to update then the topo server, calling like externally reparented operations. VT-org does all of that natively because it was built to do that. And then the requirements to make this work is you need to have at least one replica. If you have no replicas, there's nowhere to fail over to. And optional but recommended semi-sync replication if you do not want to lose transactions. Like that's been the recommendation for Orchestrator always, like use semi-sync so you make sure that you have at least one replica, acknowledge the binary log event, so you can, you will not lose data. That was it.
Right on time. Now, I know you guys have been asking questions throughout the talk. If there are any other questions, though, we do have a couple of minutes left.
Yeah?
Why not just do this in Postgres?
You can. I invite you to try.
The question also was, why not do this in Postgres?
As I said in the beginning, theoretically, there's nothing preventing you from writing this in Postgres. Just Vitess is written for MySQL from the ground up, and it's not doing an abstraction of the query language that's supported. So no, it's true. But there's been talk about doing this for Postgres. If you read Hacker News, there's basically on a daily basis people asking why is there no Vitess for Postgres?
Successful in that space. It's called Citus.
Okay. Martin?
Yeah, now you mentioned that there are some limitations in the it's not a drop-in replacement for MySQL. The limitation itself, it's in the BT gateway then, right?
Yes.
Because at the end, the MySQL backend, it's still a MySQL.
Yes. So one of the most famous limitations is the lack of support for stored procedures, because the stored procedure the stored procedure runs on MySQL, and you would need to fully parse the stored procedure syntax and everything on VTGate to make it run. We do support in unsharded key spaces. As long as you create your procedures on MySQL directly, you can call them on an uncharted key space. That's as far as VTGate supports it. There are other query limitations, like the one that I recently discovered was if you use the greatest function, like between two timestamps, MySQL returns you a timestamp data type, while Vitess returned you a varchar. And some frameworks crashed on that. What the workaround there was to, in your query, cast your result to a datetime. Yeah, but you cannot cast to a timestamp because MySQL doesn't support that. You have to cast to a datetime. So those are the kind of limitations that were edge cases that we're finding now, and you don't know or you don't believe what type of queries that your users come up with. Like sometimes you think like, how did you come up with this one? But yeah, we try to support them all. I think I know the Ready-Set guys will suffer the same problem. Like, how did you come up with this one? So it is what it is. Like if you find something like that, we will try to fix it. Like one of our developers now has a bug report upstream. Like, why can't I cast the timestamp? And why does this greatest thing do something weird in MySQL? And then sometimes you get support from MySQL stuff, but sometimes you just, they're just like, all right.
Any other questions? Yeah, please. No, go ahead, right ahead. Thank you, Matthias, for stepping up. We certainly appreciate it. I think that about does it for this room today. Thank you all. I think you have some Birds of a Feather talks starting in half an hour, I believe.
Check, check.